A warm welcome to our distinguished guests, esteemed faculty member and teaching staff. I, Mohammed Haider, along with my colleague Parth, will be your hosts for this talk. Welcome to the 4th Biennial International Conference for Future Learning Aspects of Mechanical Engineering, FLAME 2024, hosted by the Department of Mechanical Engineering, Amity University, Noida, Uttar Pradesh. I would like our coordinator, Dr. Vipin Kaushik, along with Dr. S.K. Sharma and Dr. Anup, to felicitate our first plenary talk, Dr. Dipankar Chatterjee, as a token of gratitude.
The first plenary talk of the day will be carried out by Dr. Dipankar Chatterjee. The topic of the plenary talk is external aerodynamics of a 120 mm motor. Dr. Dipankar Chatterjee is the senior principal scientist at CSIR, Central Mechanical Engineering Research Institute, Durgapur, and professor and associate dean of Academy of Scientific and Innovative Research, Ghaziabad. He has published around 200 international journal, conference papers, technical reports, 2 patents, and 6 book chapters for undergraduate and postgraduate courses. He has handled several national and international projects and developed important technologies catering to the strategic sectors of the country. He is the associate editor and editorial board member of several reputed international journals and has been featuring in the world ranking of the top 2% Indian scientists in the subject of mechanical engineering by Stanford University consecutively for the last 4 years. His main research interests are computational modeling of fluid flow and heat transfer over bluff obstacles, turbulence, phase change, and reactive flow processes, lattice Boltzmann modeling, and electromagnet hydrodynamic interactions in macro and microflows. So, we'd welcome you to address the gathering.
Very good morning. Thank you for this nice introduction. So, distinguished guests, the authority of the Amity University, the organizer, and the students, ladies and gentlemen. At the outset, I must first say that it is indeed a wonderful experience coming at this beautiful campus of Amity University. And I must thank and congratulate all the organizers for such a beautiful arrangement, so meticulously and professionally managed this big event. So particularly Professor Basant is really instrumental in organizing this big event. So thank you all, and thanks for inviting me to give the lecture on this auspicious occasion. So as said, I am a senior principal scientist at CSIR, Central Mechanical Engineering Research Institute. Actually, it is under Council of Scientific and Industrial Research, CSIR. And under CSIR, there are 38 laboratories spreading all over the country. And CMERI at Durgapur is the only lab dedicated exclusively for mechanical engineering research. Well, let them arrange, but before that, let me say a few words about our institute, what we are doing and in our institute and our group. So, as I said, that CMERI is the only lab dedicated exclusively for mechanical engineering research under CSIR. So, we have a robust product portfolio encompassing a wide range of mechanical engineering application. Starting from, we have significant contribution in the area of agricultural and farm machinery. We have a dedicated unit for that at Ludhiana, Punjab. And we have developed different kinds of tractors ranging, means a wide range of horsepower, and we have different types of power tillers, harvesters, all are in the agricultural and farm machinery category. So apart from this, in Durgapur, we have dedicated research in the area of surface and field robotics, and also the underwater robotics, and we have various products in those domain. For example, in the underwater robotics, we have developed 150-meter depth and 500-meter depth and also 1000-meter depth autonomous underwater vehicle, different types of remotely operated vehicles. So these are in this domain of underwater robotics. Recently, we have a very big project of homing and docking of underwater vehicle at a depth of 100 meter under sea. So these are some of the product portfolio of CMERI. Apart from this, we have footprint in many areas of mechanical engineering, for example, advanced manufacturing, encompassing additive manufacturing, so on and so forth. So in our group, we do specifically numerical simulation using macroscopic and mesoscopic paradigm, for example, lattice Boltzmann modeling and classical computational fluid dynamics using Navier-Stokes simulation. नहीं चल रहा है क्या? So this today's talk is basically derived from a from three sponsored projects. Two of them are sponsored by the Ordnance Factory Board, and one is SERB DST. So actually, this falls under the domain of design and development of advanced motor technology. Now, what is a motor? So let me first give you a glimpse of the physical system. For that, let me come to this topic, mechanically guided projectile. So as you can see from the associated movies, that we have a motor system, which is basically, we can see there is a barrel. Sorry. There is a barrel which we can call alternatively as a guide tube or muzzle. There are many names. So from this barrel or the guide tube, some motor boom is coming out and it is reaching to the target. So it is a guided projectile. That means it is guided, mechanically guided by the barrel or the muzzle. So mechanically guided projectile basically are short range weapons designed for use in the immediate combat area. That is for short range combat, the military is using this kind of weapons. And the main propulsion system for this kind of projectile is basically the initial kinetic shoot. I will discuss it later. Now, coming to this motor, we mean by motor the motor boom actually. So motor is usually a simple, lightweight, man-portable, muzzle-loaded weapon. It consists of a smooth bore metal tube fixed to a base plate with a either bipod or tripod arrangement and the sight. So motors are basically used for indirect fire weapons. Now, in this associated diagram, I am trying to explain, although the figure is not quite prominent here, but it is prominent here in the laptop. So you can see that this is the barrel, and inside that there is a motor boom. You can see the dismantled diagram of the motor boom also. This is typically for 120 diameter barrel hole. So we categorize different kinds of mortar based on the inner diameter of the shell, or the means inner diameter of the guide tube, or the maximum outer diameter of the mortar boom. There is a, although there is a small clearance. So this, for 120 mortar boom, the inner diameter of the guide tube is 120 So obviously the maximum outer diameter of the mortar shell or the boom is 120 So at the bottom of the mortar boom, you can see that there is a firing pin type arrangement. So when the mortar boom is put inside the barrel or the guide tube, due to the kinetic energy of the mortar boom, it will hit the firing pin, and at the back end or the tail end of the mortar boom, there is some arrangement of combustible material, which is a black pellet, and that black pellet will be ignited as a result of this kinetic energy transfer. So when the black pellet is ignited, there will be some combustion product, and that combustion product will go into the innermost part of the motor boom, which is called the flash tube, not quite prominent from the figure. Inside the flash tube, again there is some combustible material, and that combustible material will be ignited. The flash tube is perforated, so the product of combustion will come out from this perforation, and it will go to the next stage of the motor shell, that is called the tail boom section. And inside the tail boom section, there is again some combustible material, which is a kind of M48 ball propellant. So that ball propellant will be ignited, and finally this and also you can see that there are 4 ring type of charge. These are also combustible material. So depending on the need of your range, you can ignite. You can use 1, 2, 3, 4 different states of charges. So overall, what will happen? The products of combustion will be ejecting in, will come out, and it goes into the open space of the barrel. So finally, there will be a very big pressure development, but this will happen in a very small time frame, that is in the order of milliseconds, some few milliseconds. And as a result of this high pressure generation, the motor boom will be ejected from the guide tube. So this is altogether the phenomena. Although I am not going to the details of this internal phenomena, I will explain only the external phenomena today, but because this involves lot of things inside this the phenomena that is occurring inside the barrel. So this is altogether the phenomena. As a result of this, the motor boom will be ejecting. So coming back to the to our today's discussion, so we will consider today only the external ballistics. Actually, the ballistics can be broadly classified as internal ballistics, external ballistics, and terminal ballistics. In case of internal ballistics, as I have discussed, it is when the motor boom is inside the barrel only, the phenomena that is occurring, the ballistics phenomena that is occurring inside the barrel only, that is the internal ballistics. And when it moves from the barrel up to the target point, it is called the external ballistics. This is very important because many aerodynamic forces and moments act on this particular projectile. So that will dictate the trajectory or the path of the projectile. And finally, when it reaches the target, the lethal action can be actually felt. So the motor boom, there is an arrangement at the motor boom, a fuse arrangement is there. So the fuse, when it hits, the nose hits the ground, as a result of this, there will be a bombardment of the bomb, and it will spread over certain area. That is basically the lethality of the motor bomb. So this is called the terminal ballistic. Now we will concentrate only the external ballistic part for discussion today. So now, in the external ballistics, one very important aspect is the stabilization of the motor boom. So unless it is properly stabilized, so there will be means the motor bomb may deviate from its path, from its trajectory, and where the military person want to hit, it will not hit that particular target, it will hit some other place. So that is a big challenge for the motor designer to make it fully stable. So there are different types of stabilization technique available. So one is the fin stabilization. So in case of fin stabilization, what we do, we try to rotate the motor bomb inside the barrel itself. So for that, we need to create some groove type of things that is called rifling inside the barrel. And as a result of this rifling effect, the motor bomb starts to rotate inside the barrel, and when it is means when it ejects from the barrel, there is a spin of the motor bomb. So that spin is actually causing some gyroscopic action, which keep the nose of the projectile aligned with the axis of the projectile. So that is called the spin stabilization. So another way of stabilizing the projectile is the fin stabilization. So in case of fin stabilization, we use certain number of fins at the tail end of the projectile, and that is basically increases the drag behind the projectile such that the nose means nose pointed in the direction of motion. So that is the fin stabilization, and normally we use say maximum 10 number of fins, and also it should be kept in mind that the fins should be such that the number that the projectile should remain symmetric in nature and geometry. So here we can so this can be achieved by two different ways. One is by moving the center of gravity of the at the front end of the projectile by load redistribution, that is called dart stabilization, or by shifting the center of pressure rearwards by introducing aerodynamic forces at the tail of the projectile. So this once again can be achieved by two ways. One is increasing the tail drag by introduction of fin, that is called drag stabilization, or by increasing the lift force at the tail, that is called wing stabilization. So these are the two different ways, either spin stabilization or spin stabilization. So in the modern subcaliber projectile, we sometimes use a hybrid type or mixed type of stabilization, that is a combination of both spin and fin stabilization. So what we do, we just make the fins slightly angled, that is called canted fin, cant angle. So as a result of this angled fin, there is pressure imbalance on the two sides of the fins, and there will be means the projectile will be rotated without giving a spin by the rifling action. So only by the canted fin we can generate the spinning effect, and as a result of this, both the spin and fin stabilization can be achieved. So this is another way of stabilization, mixed stabilization. Now we will come to the modeling techniques that we are adopting for accurately or for estimating accurately the projectile path or the trajectory. So there are various approaches, and all the approaches have their pros and cons. So one is the vacuum trajectory model, first one. So in this vacuum trajectory model, we can understand from the name itself that there is no air resistance, only gravity acts on the projectile. So in this case, you can simply understand that this will be a parabolic path, and this model is accurate for short distance projectiles. Now, a little modification is there, that is called point mass trajectory model. Here we consider the projectile as a point mass with no dimension, and the forces are gravity and aerodynamic drag. So this is the point mass trajectory model. And then we can consider also linear drag trajectory model where air resistance is proportional to the velocity. We can also consider modified point mass trajectory model. Here we extend this point mass trajectory model by additional factors such as by incorporating the Magnus effect, wind drift, and more accurate drag models. So this is modified point mass trajectory model. And finally, we come to the most comprehensive modeling strategy, that is the 6 degree of freedom model. So in this 6 degree of freedom model, what we do, we assume that the projectile is a rigid body of finite length and the mass is distributed based on its geometry. So it considers 3 rotations and 3 translations. So altogether the 6 degrees of freedom. The rotation of the earth and the spherical shape is also taken into account while formulating the 6D model. So here what the methodology is like that, we consider 2 different coordinate system. One is fixed with the earth, say at the launching point, noted by say 1, 2, 3. These axes are tangent to the earth surface, say at 1 and 3, and 2 is perpendicular to the earth surface. And another coordinate system that is designated by x, y, z, this is attached with the projectile body. So now the most important part is the identification of various aerodynamic forces and moments that are acting on the projectile body during its flight. So the most important aerodynamic forces are the drag forces and lift forces. Then we must consider, since it is a spinning body, so we must consider the Magnus force and also the pitch damping force. So these are the relevant forces. Apart from this, we have certain relevant moments, which are Magnus moment, spin damping moment, overturning moment, and pitch damping moment. Now here there is some important things regarding the calculation of this coefficients. You can look into this coefficients, that is the drag coefficient CD, lift coefficient, and there are all equations are incorporated with some coefficients. Now these coefficients are not a fixed quantity, means a constant quantity. They are also having 2 components. One is the fixed component, that is the 0 yaw angle component, and another one is since the projectile is continuously changing its direction, so that means the yaw angle is continuously changing. So as a result of this, there is an influence on drag, on lift, on Magnus force, all the force and moments. There are some influence of this dynamic trajectory evolution. So as a result of this, there are components of the influence of this phenomena on the drag coefficient, lift coefficient, Magnus force coefficient, everywhere. So these are not simply some constant; these are variable quantities, and this depends on the yaw angle also. So now another important thing is the Coriolis force. That is very important when we are considering the long range projectiles. For short range projectile, this does not affect much. But for long range projectile, as you can see, for the student, you can understand this quite beautifully from this figure, that if there is no earth rotation, so something when on the left hand side, something which is launched at the north pole, it will go straight along this 90-degree latitude longitude. And when you consider that there is a rotation of the earth, now you see that what is launched at the north pole, it will not directly go to the 90-degree location, it will reach to the 105-degree location, since the earth has already moved a little bit. So that is why we must consider the Coriolis effect for long range projectiles, and all the calculations are expressions are there for this Coriolis effect. So now the overall system of equation. So we have from the Newton's second law of motion, we have linear momentum conservation and the angular momentum conservation. We are also considering here, this is the generic equation, so we consider the rocket thrust force, although it is not important for motor calculation, it is important for the rocket trajectory. So this is the complete means the system of equation. Now from this system of equation, we will incorporate all the significant forces and moments that we have already discussed into these equations, and finally or eventually we come out with this 6 set of equations, 3 showing it, 3 for the x translation, y translation and z translation, and 3 for the roll, yaw and pitch. So these are the 6 differential equations. These are the 6 equations that we have got, and we solve it by say one step fourth order Rangakutta method. Actually, you can use multiple step Rangakutta method also, but there are some certain pros and cons of this 2 methods, one step and multiple steps. I'm not going into the detail of this intricate issues of modeling. So we use single step fourth order Rangakutta method for solving of this 6 set of equations. These are the some initial conditions we apply, and again the initial conditions. So with this, now the most important parameters which we are interested to obtain from this simulation is that one is the translational parameter, that is the position of the projectile, which involves the range. Range is the maximum distance that the projectile can be achieved. Another one is the altitude, this is the height, maximum height. Drift, drift is means the deviation of its path as a result of maybe earth rotation, maybe wind effect. So this is drift. The velocity is an important parameter we need to understand. Rotational parameter, there is roll, pitch, yaw, and several other force and torques that are important to estimate. So now the validation of our model, we validated our model with the 105 millimeter projectile that is available in the literature, and the details of the parameters are given here. So you can see that the validation gives us means a quite encouraging result. The altitude and the range are here estimated for different for a marginal velocity of 205 meter and different quadrant elevation angle, that is the launching angle of the projectile. One is 45 degree, another one is 70 degree. And for both the cases, you can see that the model prediction and the literature result are absolutely fine. Now, I must comment here that all these coefficients that we have discussed, the aerodynamic force and moment coefficients, these coefficients are means it is very difficult to obtain these coefficients numerically. So we must rely on experimental techniques, that is wind tunnel technique or spark photography technique to obtain this. Now there are some commercial, not exactly commercial, some softwares are available that is called PRODAS, one important software, PRODAS, that is Aerolab USA. But the thing is that they are means not selling the software to means normally they are not selling the software. Once I contacted them to because to carry out 2 of our important projects, that is design and development of 60 mm and 81 mm motor for OFB. But they told that you need to take your clearance from the defense ministry. So it is not possible to get all these sanctions. So we started to write all these codes although we cannot means it is very difficult to produce such a robust software like PRODUS, but we have tried, and we have come out with some solutions for this internal ballistics also. And the external ballistics, you obtain this 6-degree of freedom, complete set of 6-degree of freedom model, which is quite comprehensive, and we can predict 60 mm, 81 mm, 120 mm and 105 mm mortar system with this software system, with this code. Now, okay, so these are some again some validation, that is the drift for 1 by twist, 1 by 18 twist and 1 by 25 twist. This means that the rifling effect that we are just discussing, once it so you can see how the results are matching excellently with the literature result. So this is the mortar system that we have developed, 120 mm. This is out of our own interest. We have developed it, and this project has been sponsored by, as I said, that this is sponsored by ACRB DST. But we are not showing all the dimensions here. This is the 120 mm projectile, and the overall dimensions are there: the reference diameter, projectile tail length, weight, axial moment of inertia, transverse moment of inertia, and center of gravity. These are required preliminary for all those calculations. And these are the aerodynamic forces and moments that we have obtained from the literature. There is a standard. This is called STANAG, STANAG, STANAG standard of NASA. So we use that standard for calculation of this. Now you see, this is the variation of the altitude and the horizontal range for different marginal velocity of 102 meter per second and 318 meter per second for 3 different elevation angle: 45 degree, 65 degree and 85 degree. So you can see that at 45 degree the maximum range is achieved, and as the elevation, as we increase the launch angle, we get the more and more altitude, but we need to compromise with the horizontal range. But the most important thing is we need to achieve the range. So I think 45 degree is the optimum elevation angle where we can get a good altitude, also a good range. So these are the drift with range for different marginal velocity and quadrant elevation angle. And one thing I need to I am skipping this. One thing I need to these are the pitching profile. This is again very important, and you can see that at the at 45 degree and 65 degree elevation angle, the pitch does not fluctuate much, but at higher quadrant elevation angle there is a big fluctuation of the pitch motion of the projectile. So now the important thing is the effect of wind. So you can understand from this how the different kinds of winds, such as the tailwind, headwind and crosswind, are affecting the trajectory of the projectile. If there is a tailwind, that means the projectile is there will be it favors the motion. There will be larger range can be obtained. In case of headwind, it actually opposes the motion. And for crosswind, there is deviation either from positive direction or from negative direction. You can see that there will be a deviation from the of the projectile path. So let us see how it actually affecting. So here we have the range versus wind velocity plot. You can see for different marginal velocity, 102 meter per second and 318 meter per second. You see that the tailwind is actually increasing the range, whereas the headwind and the crosswind is actually reducing the range. And this is the or range versus a drift plot. So you can see the tailwind, headwind, and finally the for the crosswind, positive direction and negative direction. In both cases, there is significant deviation of the projectile path. So overall, in summary, we say that this we have developed a 6 degree of freedom, complete 6 degree of freedom model to understand the flight dynamics and to estimate the trajectory of the projectile accurately. We consider several aerodynamic forces and moments such as Mach number, total angle of attack, variable and constant aerodynamic coefficients. We obtain the flight trajectory for muzzle velocity 102 to 318 meter per second for a wide range of elevation angle. And the results are validated with 105 high explosive M1 projectile with the literature. And this result associated with 120 motor are quite encouraging to predict the range and altitude of the projectile, and that can be applied for any such kind of guided projectile system in future. So thank you for your attention. Thanks. And if you have any queries.
So very insightful and very nice presentation. So this
Thank
fin
you.
stabilization is it static structure or is it changing? The fins are movable and being dynamically adjusted real time.
No, we don't go up means at this advanced level. We only consider that there is either a static structure, means either a symmetric arrangement or a canted fin arrangement. There is no means dynamic.
Fins cannot move.
No.
Because many times what I've seen in they are adjusting the flight. So how they are adjusting the flight?
It is possible. We are adjusting by say this canting of say, as I said that there are 5 to 10 number of fins. So the cant angle is means varying from one varying means this direction is varying from one fin to another, such that there is a almost symmetric arrangement.
No signal is sent from ground or something to adjust.
No.
Thanks.
Good morning, sir.
Morning.
Your presentation was excellent.
Thank you.
So I have a small question. In fin stabilization, because number of fins and dimensions are fixed, it will work when environmental parameters, how it will work when the environmental parameter due to storm, etc. will change.
Yeah, but that we don't consider at this moment how it will change during storm, etc. Means we also only consider the wind effect. Means yeah, we have considered it, but it's a high storm. We have not yet simulated it. For the wind velocity shown up to 15 kilometer per hour, we have considered, and we see how the drift is achieved. Yes.
Very nice lecture.
Thank you.
I have just two questions. First is, how many variables you have considered for the first problem in which you have used Rangekutta method?
How many
How many variables?
variables?
Was it a single variable problem or it was multivariable problem when you have used Rangekutta method?
But it's multivariable, obviously.
One variable. Okay. And which order of Rangekutta method?
Wait.
Which order?
It's fourth order.
Okay, the common one.
Fourth order, one step, fourth order.
Okay, thank you.
Okay, thank you all once again.
We would like to thank Dr. Dipankar for addressing the gathering and for sharing his thoughts on the topic. Sir, your insights and expertise have greatly enriched our understanding.
Now I request our faculty coordinators, Dr. Aketyagi and Dr. Shyam Samant, to felicitate Dr. Dipankar Chatterjee.
The next plenary speaker is Captain Dr. A.V.S. Murthy from Naval Science and Technological Laboratory. Now, I would like to request our coordinator, Dr. Prem sir and Dr. Ajay sir, to present the Tulsi's happening to Dr. A.V.S. Murthy. The topic for the talk is Captain Dr. Evan is a notable figure associated with the Naval Science and Technological Laboratory in India. He has made significant contribution to naval research and technology, particularly in areas such as underwater system, torpedoes, and other defense-related technologies. His work at NTSL, a, pr- a primary laboratory under the Defense Research and Development Organization (DRDO), has been instrumental in advancing India's naval capabilities. We would like to thank
Good morning to you all. At the outset, I would like to thank the management of Amity University, the organizers of FLAME, and most importantly, given that today is a holiday, I think I should thank all of you for being here to hear us. We have come from outstation, but you have braved the holiday warning not to come to the college, and still you have come. So my sincere thanks to all of you for being here and trying to hear out what we have got to share. When I received the mail from Dr. Basant Singh, these are the areas which have been given to us, saying that we have got to speak on one of these areas. But that was a little difficult thing to say, because your professors probably would be much better off telling what is the state of art in these areas. So whenever an engineer has any doubt, you should always go back to the only movie that probably glorified a mechanical engineer, Three Idiots. So I assume that all of you would come here with an open mind and listen to, as you have seen across the board. Yesterday we had somebody speaking on mechanical, then electrical, then civil, and today seems to be the defense day. So I hope you all have come to hear us saying kuch naya seekhne ko milega, maza aayega. So we will try our best. Someone has spoken on the ballistics. I'll now be speaking on infrared suppression systems, and my colleague will then be speaking on electro-optical systems. So it is more of a defense, but I'm sure you would like to enjoy the day. Fine. As I said, I'm a practicing engineer, unlike my predecessors, who are very good in mathematical things. I've spent 18 years, the first 18 years of my life on board naval ships, trying to operate and manage right from 5 horsepower pumps for fresh water to 22.5 megawatt LM2500 gas turbines. So I'll keep the maths most of the time out. It'll be more of a story. So first I would like to give the big picture, then some technical gupshup on naval stealth, and then finally, how is it relevant, whatever we are speaking to you. So first, the big picture is, why do we need Atmanirbharta in naval stealth? What is India's maritime strategy? Do we have a strategy? Are we aligned towards that? As per India's maritime strategy, there are 3 spheres of influence that we would like to exert in our neighborhood. The first level is in the littoral waters, which are just adjoining us, and the Indian Ocean region, which is adjacent to us. Here we would like to have complete dominance. We would not like to have any enemy ship coming and entering into our waters without our knowledge or taking any action that is not in the interest of our country. Then the second level are the strategic choke points, that is from the Gulf of Aden to the Malacca Straits, where we have the Indian ships moving around and getting us something like oil, something like weapons, anything that is of relevance to us. So here we would like our naval ships to accompany them and to ensure that they have a safe passage. And the third level is where we would like to have bilateral and multilateral friendship. Someone like Japan on one side and probably the US on the other side. So you keep hearing in the newspaper about various exercises that we have, Malabar, Quad, etc., etc. So this is the broad picture because of which we would like to have Atmanirbharta. So who is worried about our friendship? Obviously our neighbor to the northeast. So the Pentagon estimates that about 62% of Chinese oil and 17% of natural gas import transit to the Malacca Strait. So then what? Tomorrow if China attacks Taiwan, the biggest worry they have is that India and other countries are able to intercept whatever oils that are coming. It's something like this. And we will be able to stop them from actually reaching that oil and for them to continue the war. So the Chinese have developed something called as the string of pearls. These are Chinese network of military and commercial ports. You would have heard about Hambantota port in Sri Lanka, the Gwadar port in Pakistan. So they also use this depth trap diplomacy so as to take control of ports in foreign waters, so that our sea lines of communications are cut off for us. What do they use these ports? They also use these ports to collect information, the signature of our ships, so that tomorrow they can fine tune their mines, their torpedoes and all to go and attack our ships. So it is very important that we do not allow this to happen. So what is the answer to this intelligence gathering that happens in the peacetime? That is naval stealth. So this is the big picture as to why we need naval stealth. What is the implication of it at a global level, literally at a global level? Now, stealth is not something that is new or something that we have invented today. It has been there right from the early or ancient man, or even the first animal that stepped on the land probably would have used survival techniques. So the first time it was put in the mankind literature is that by Arthashastra, Chanakya, secrecy and dissolution are essential to war. The Chinese too have their own Sun Tzu, who is very, very famous for, he says that all warfare is based on deception. So why do we need stealth at sea? Because there has been advancement in missile technology. There has been advancement in sensor technology, so we are able to capture the ships from far away. There has been underwater weapons have become more accurate, and stealthy aircraft are all the time circling us and are, you have heard about the Chinese balloons, they are collecting lots of information. So the answer to all these problems is a stealth ship. So how does stealth help? It delays detection by the adversary. It increases the performance of our own sensors. It enhances the effectiveness of hard kill and soft kill. Hard kill is that we ourselves fire a torpedo or a missile to bring down an enemy torpedo or a missile. That is a hard kill, where you are literally, hitting it hard. The soft kill is we use decoys. So when somebody fires on an aircraft, you see in the movies, they fire the flares so that the enemy missile gets diverted. For the torpedoes, you have torpedo decoys like Marich, which NSTL has made. So all this, what does it do? It reduces the vulnerability of our own platform and therefore increases the chances of survivability and completing the mission that has been allotted to us. Why do we need Atmanirbharta? Why can't we just buy these items from the foreign companies who are more than willing to sell them? One, most of the time the so-called transfer of technology is only for manufacture, operation and maintenance. Nobody gives the know-how or the know-why. And literature on most of these stealth signatures are not available in open literature. Even if you say the Janes, which gives all the across the world, all ships information as to which propulsion it has, which armament it has, it doesn't talk about stealth. It doesn't say whether there is some methodology which is used to reduce the signatures. And also, since it is exclusively military use, there is still technology embargo. Even the US still does not supply the IR suppression systems which we have developed. It's still in the list of embargo. Therefore, each country needs to develop its own expertise. Okay, so the theory is over. So now let's look at the technical part. What are these signatures? Just like a human being has eyes, ears, nose, by which the film stars are identified just by their eyes or nose. So the ship has also got certain signatures. So as you can see them, one is the airborne noise, infrared, acoustics, laser, radar signature, which is most common. BrahMos and all are based on capturing the radar signature of the ship. Then the magnetics, ELFE,
and ship wake. So the top three are basically mechanical signatures, and I will cover them. The bottom ones are electrical. I have a couple of slides toward then, but I will avoid. Just to give an overview, radar is basically based on the shaping of the ship. So a radar wave impinges and goes back. So therefore, it paints on the radar. Laser is the latest technique. Radar is in mm and cm, whereas laser is in nano. So therefore, even if you give any kind of angle, all these fancy angles that you see are of no use, because as far as the laser is concerned, it is like a 90-degree wall only, because it is of nanometer wavelength. Magnetics, ship is basically a piece of iron, and a mine which has got a magnetic sensor will be able to trigger. The Nexels also use it quite often. ELFE, this is extremely low frequency emissions. These are basically alternating currents which are used. This is one of the latest technologies which is being used and is still at a nascent stage. The ship has got corrosion protections. Again, it is in seawater, so therefore corrosion happens, and whenever corrosion happens, we have eddy currents which are formed in that area. So anodes are put on the ship to prevent the hull from corroding. And also we use something called as ICCP, that is impressed cathodic current protection. So current is impressed. These are very low voltage currents, but they travel a very long distance in the sea and can be used to wake up the mines. The ship wake again is a very new method. When the ship passes, this is the kind of wake that you see, but more than that, there will be small droplets which are formed, which remain like that for almost 24 hours. So a torpedo can actually follow the ship based on the wake it has created. So I'll not be going into depth of all this. I'll be covering the top three in more detail, since it is more about, flame is more about mechanical engineering. Okay, first, infrared. Every body that is above 0 Kelvin transmits in the infrared wavelengths, which are from 0.75 micrometer to 1000 micrometer. The term was coined by Sir William in 1880, which literally means below red. Thankfully to us, while it transmits in such a long wave range, only there are two wave bands in which it travels for a longer distance in the atmosphere. That is just atmosphere, 3 to 5 microns and 8 to microns. So as suppressors, we are only focusing on these two wave bands. So what is the difference between IR radiation and IR signature? IR radiation is when a body gives out radiation. When the same radiation is used by a missile or any other object to sense that particular object and target it, it becomes a signature. And infrared homing is preferred for terminal guidance of the missile because of its inherent immunity to jamming techniques, unlike radar, which has to transmit. So therefore, the ship also comes to know that there is a missile which is coming with radar seeker. And also the transmitted wave can be jammed, whereas in IR it is a passive signal which is going from the ship, so therefore there is nothing called as jamming. Now, are there anti-ship missiles with IR seekers? Yes, plentiful of them. But if you see the names, sometimes you may feel they are all friendly countries. What is so worried? Well, the Chinese also have rolled out a large number of these missiles and are happily supplying to our friendly neighbors, Pakistan, Thailand, Indonesia. So what does the missile see? So actually everyone calls infrared as temperature, but it is not exactly temperature. The missile sees the radiant intensity, which is given by Boltzmann constant, that formula which you can see there. Of these, once the ship is made, the Boltzmann constant is of course a constant. Emissivity is basically a paint. It depends on the kind of, it's a surface phenomenon of the paint. So once you have fixed the material or the paint, it becomes constant. Once you construct the funnel, area becomes constant. It's only the temperature which is variable, which depends on the kind of loading that you do on the engine. So therefore, most of the time IR is considered as a thermal signature. So what are the sources of infrared signature? As you can see on the left image, when the missile sees the hot exhaust duct and the plume, they are the major emitters, and even the hull, which gets heated up because of the solar loading up to almost 60 degrees, whereas the adjoining waters will be around 30 degrees or 35 degrees, is also a source of IR radiation. So how has IR suppressors evolved. Initially, there have been no suppressors. Then people started using acoustic and thermal insulation all around the exhaust ducting and also doing manual wash of the decks. Then came the level 3 IR suppression passive, and now presently state of art is active mist system. I'll be explaining them in detail. Now, what does all this happen? All this gives additional time to the ship. So on the right, you see the ship has detected a missile first. But how much time does the missile take to detect the ship? That is important because he's the one who is coming to attack us. So if there is no suppression, you get 8 seconds. And with all this so-called state-of-the-art suppression also, you get 70 seconds. So you can imagine the kind of panic that's why you see in the English movies, no? When the moment there is something seen, there's a lot of sudden increase in the pitch and frequency of what the people say. That is all because you hardly get about 70 seconds to really defend yourself through either soft kill options or the hard kill option. So what is this level 3 IRSS exactly? So when the exhaust duct is without IRSS, it is what you see on the left hand side. It is a straight duct. So there is no drop in temperature in this. And the structural modification which we do when we keep an IRSS is that we remove the duct and we keep something called as a nozzle. So there is an increase in velocity. Then there is a gap which we leave where you can see the air entering, cold atmospheric air being sucked inside. So we leave a gap that is called standoff. And then we have mixing tube and the diffuser rings. How does this exactly work? Just let me see if the animation works. Yeah. So here we are taking a hypothetical case where about 300 odd degrees temperature is there at the inlet. So when it is going up, you can see the ambient air being sucked in from the sides because there is an increase in velocity and a drop in pressure. So now this ambient air gets mixed up and you can see the temperature changing from red to green and then to first to yellow and then to green and then blue also. So, and the diffuser part is what you have to observe carefully, where this ambient air forms a thin film. So therefore we reduce the temperatures from almost 520 Kelvin to almost 30 degrees, that is around 300 Kelvin. So NSTL has got a patent of this as old as 2005, and we have been manufacturing these devices. Now, what are the constraints in developing this, the engineering design challenges? One, of course, is the main thing is the space constraint in the funnel. Like just like an aircraft, the ship's funnel is also very compact, and therefore we do not have the freedom of going for the optimal design which most of the literature gives for a nozzle or for a ejector device diffuser. So what are the constraining factors? If you see the diffuser rings, which you see on your left hand side somewhere here, the more the gap between the rings, higher the amount of cooling, but larger becomes the exit diameter of the funnel, which is not acceptable because then it paints bigger on the radar. Then we have the mixing tube. Obviously, the longer the mixing tube, better is the mixing, but reduced will be the length of the diffuser. The diffuser is where we reduce the temperature by about 90% because of this film cooling. So therefore, we don't want to reduce that view angle protection. Then we have the standoff, that is the gap between the ejector and the mixing tube. More the gap, more the ambient air, but then the exhaust gas may spread out and come out in case we keep too much of a distance. The ejector, smaller the exit diameter, definitely more the velocity and more, therefore more the ambient air sucked in. But this induces higher back pressure, because of which the propulsion power of the engine reduces and the ship will go slower, which is definitely not acceptable. Now, the state of the art level 4 IRSS systems, the leftmost picture that you see is how it is fitted in the funnel of a ship. Below that you see a gas turbine, and then here in level 4, along with ambient air, we use water mist. So you can see on the extreme right, water mist, and the nozzle arrangement which is done on the ejector, so that water can also be, so the latent heat of vaporization is used to absorb more heat. And we have a flow control mechanism because the gas turbines need about 22.5 tons approximately of water, whereas a diesel engine which has got a much lower power needs only 2.5. So how do you, from the same pump, how are you going to give both is a difficult task. So the these are all pure mechanical systems. When you are designing the nozzle subsystem, the most important point is the droplet dwell time. That means what we do is in the CFD, once we do the passive, we introduce one droplet of say 100 microns and we have a height of about 10.5 meters. So we calculate what is the time it is taking to evaporate, and we try to keep increasing the size of the droplet so that we obtain the maximum droplet which will evaporate. And then we have to go to the commercial nozzles to see which all nozzles have got 80% of the droplets that are evaporating. Because and you have to calculate, like as I said, LM 2500, say let us say it is at 560 degrees, about 80 kgs per second. We have to drop it down the exit to same 80 kgs, but to say around 100 degrees. So there is a quantum of heat that we need to remove, MCP/dT on one hand, and the other hand will be latent heat plus the sensible heat that we are removing through these droplets. As I said, pumps, CODOG is basically combined operation of diesels and gas turbines. This is a kind of propulsion where the ships have two gas turbines and two diesels. The gas turbines are there when you are in an attack mode and when you want to go very fast, but they consume lot of fuel. So therefore, you have two diesels, main diesels, which are about 5 megawatt. The gas turbines are around 25 megawatt. The main diesels are about 5 megawatt and they are used for the cruise operation, which is 80% of the time. So, but therefore the mass flow rates also like that. As I said, gas turbine has about 80 kgs per second, whereas a 5 megawatt diesel engine will have about 10 kgs per second. So therefore, the amount of water that is required, water mist that is required is different. So we need to understand how to control the flow. Then of course, the control system and instrumentation, RTDs and thermocouples to capture your temperatures. Drainage and blow through, we are using seawater because fresh water is a premium at sea. So therefore, I have to use seawater, and when I use the seawater, when the system is not in use, you always have the problem of salt choking these nozzles. So therefore, you need to have some kind of a drainage and blow through system to keep your nozzles clean and available. Material studies, so seawater mist is used and at high temperature, therefore you have to choose materials like SS321, SS316, 304, you have to choose which is the best method. And of course, for a warship at sea, the most important things are shock, when some underwater weapon breaks, or noise, or vibration and fatigue. So these studies also need to be done. I'm not, as I said, getting into all this because this is actually the technical part that we do on a daily basis. But any technical part is always boring when you try to explain. So these are the various applicable standards which are there. We need to follow all this. So I'll just leave it at that. It is not easy to design these systems. It takes time. Not rocket science, but at the same time, it takes time. So what is the role of NSTL or DRDO? We support the Navy right from design to the delivery. So first we do mathematical modeling, then we do a 3D modeling, then do meshing, then we do n number of iterations of numerical simulation, then we fabricate a prototype. We have built test beds at NSTL for the diesel engine and at Naval Dockyard Visakhapatnam for the gas turbine, and then finally the shipboard installation, commissioning and trials. So now if you see these and try to combine with what has been given for flame, the topics. The first part probably comes under engineering design and industrial engineering for design optimization. I'm an industrial engineering myself. So the design optimization studies typically come under industrial engineering. Then you need to have knowledge of fluids and thermal engineering when you are doing your CFD simulations and numerical simulations. What kind of material will you use? How the manufacturing drawings are to be made? And for the sea environment, which is the best kind of nozzle, like when you are in high temperature, we use Inconel. When you are using seawater and there is no temperature, we use cupronickel 9010. So you need to have good idea of materials as well as the production engineering. And of course, installation on the ship, where you have to integrate your system with the shipboard, LP air systems, the seawater system, the IPMS integrated platform management systems as to when to switch on this, when not to switch on this. So therefore, it's a multidisciplinary engineering. So all aspects of mechanical engineering are covered when you design any such small system also. So where is this IRSS system fitted inside on the ship? It is unseen from the outside. It is stealthy. It is strategic. And as I said, it is not indicated Janes or other publications. So what you see, this is the gas turbine. What you see at the bottom, and this is the exhaust ducting, and on top of that, this is the IRSS. It just comes out, but it is surrounded on the outside with the funnel so that it is not visibly seen. So therefore, you do not know whether the Chinese or the Indians have fitted IRSS system in their ships or not. So how is the detection of the ship? As you can see, unsuppressed ship, you are able to clearly see the heat points, and during the day you are not able to see them in case you are using a suppression. Sorry, the right side is a suppressed ship, my mistake. Again, I think we interchange the names. This is a unsuppressed ship at night, and this is a suppressed ship at night. So what have we done till now, or is it just talk and theory, or have we done something? Yes, we have done something. We have handed over about 180 numbers IRSS systems for both gas turbines and main propulsion design on about 48 naval platforms in the last 10 years. We have also got them included in the third positive indigenation list. They are at serial 13 and 14. So we have achieved Atmanirbharta in infrared stealth. What are our future actions? Yes, we are trying to spread our wings. We have tied up with HAL and a company called WEM Technologies for designing IRS systems for the light combat helicopter Prachand, as also with CVRDE for the light tank. For the forthcoming, all surface ships are going to have IRSs, and we are also looking at exploring the export potential with friendly countries like Philippines and others. So this is the NBC wash and pre-wetting system. This is the next area where we are trying to work out. As I said, till now we have worked on the IRSs is predominantly for the exhaust. So as you see presently, the NBC pre-wetting system, has got a kind of a fountain kind of thing which comes out. This is designed more for the NBC's nuclear, biological, chemical contamination to remove them. So it is pre-wetting. So you wet the deck before you enter into a nuclear, biological, chemical zone where you get information that it is likely to be there, so that those particles do not adhere to the surface of the ship. Now we want to change these nozzles in such a way that they are able to also cool the system. So the hull temperature prediction due to solar loads, we do not have any non-dimensional number for hull plate temperature for transient loads. So it is an area where the academicians can work. And also we would like to adapt A and ML to control the hull temperature. Then nanomaterial based exhaust plume cooling we would like to do, and infrared image based missile lock on range estimation. These are areas where we are looking at. I will skip acoustic stealth and vibroacoustic. These are all areas which I got about 7 minutes. So this is another important area where we are working on, that is the propulsion system integration. Till date, Indian Navy has been dependent on foreign vendors to give a solution. We want to develop an indigenous expertise in this area. These capabilities are on the areas which I have indicated on the slide. Someone interested can meet me separately. We can look into them. Now, again, these are the areas where we are doing right now. So the relevance to flames, well, the role of academia and industry, these are the 4 areas with which the DRDO is trying to reach out to academia and industry. Naval Research Board, DRDO Industry Academia Centers, Technology Development Fund, and IDEX program. Quickly run through. So research boards, there are 4 research boards in DRDO: Aeronautical Research Board, Armament, Life Science, Naval Research Board. They take up when the TRL, that means the technology readiness level, is 0 to 3. So that is where the academia are mostly going to pitch in. Then we have the Naval Research Board. For example, out of these 4, I'm just focusing on that. So there are 7 specialist panels in that. These are the areas. So this is the process that you need to send any project that you have to the Secretary NRB. Then it will be sent to the labs. The labs, if they show the interest, then the principal investigator will be asked to put a detailed design. In the last 25 years, about 142 academic institutes have carried out 490 projects worth about 150 crores. This is as old as March 22, so many more have been done since then. DRDO has also set up industry academia centers of excellence, around 15 of them. I'm sure MIT will also be asking for one soon. Presently, IITs and some other institutes have got one. These are where we have a TRL between 3 to 7. That means the basic literature is done, and we want academia to partner with industry and DRDO so that we will be able to take it from that level to a prototype or a demonstration of a physical item. The core areas for each COE are available on the website, so people can see that. The detailed proposal is to be submitted to the institution COE. The next is the Technology Development Fund. It aims at funding defense and dual-use technologies. It is established in 2016 for projects which are less than 10 crores in cost and 2-year development cycle. As of March 22, about 41 projects worth 205 crores have been done. So there are grants are given to the development agency who can work in collaboration with academia or research institutes. It is only for development of technology and prototype, not mass production. The academia role should not be exceeding 40%. So the types of projects are as shown, basically to take them again from TRL 3 to 7. Then these are the recent TDF projects which has then been in the news in 11 July 24. So people are extremely aware of this in the higher echelons and they're using it well. The last is the Innovation for Defense Excellence. This is for the startups, which has been launched in 2018. And about rupees 500 crores, 498 crores has been allotted between 21 to 26. And the target is that 300 MSMEs or startups or individual innovators and 20 partner incubators need to be funded through this. And you just have to show the capability, intent, and promise. You will be given as much as rupees 1.5 crores per applicant. And they have also established clusters which are focused on specific military platforms. So they have this Defense India Startup Challenge. So the expected outcome is foster innovation and technology, and at least 60 solutions are required to be developed before 2025. That is the government agenda. They are also tied up with India-US Defense Acceleration Ecosystem Index X, wherein whatever you are developing here are likely to be accepted by the US also, so that you get a bigger market base for this. As far as there is an IDEX investor hub which has been launched during Aero India 2023, where 9 major companies have pledged to invest about 200 crores. So this is where is a incentive to all the academia to get into this area. Okay, fine. This is my conclusion. Have we incorporated stealth in Indian Navy? Yes. If you see Delhi class, and this is the Visakhapatnam class, so you can see visible changes in the outer structure. These are the Godavari class of the 70s and 80s. This is the Shivalik class. Now 17 Alpha is coming. That is even more stealthier. This is a semi-stealth ship, Shivalik class. This came in 2010. This is the Kukri class, and this is the Komodo class, which is come somewhere in 2018. That's it, and thank you.
First of all, thank you, sir, for your beautiful and such a knowledgeful presentation. So I have a small question. In infrared radiation, if the parameters like outer surface, surface temperature, outer curve, etc. of ship, if such parameters are considered in IRSS?
Yes, definitely. See, basically what happens is in infrared, typically initially we concentrated on insulation on the outside. But when the missile sees, it sees the internals of your exhaust duct. So previously people used to be happy doing insulation on the outer side, on the exhaust. And as I brought out, it is like suppose you are going on a dark road and there is a huge big light and there is a small light. Obviously everyone looks at the bigger light and not the small light. So the exhaust duct which radiates in 3 to 5 wave band is the focus of most missiles. So most of the missile IR seekers were on that. But today, since maybe early 2000s, almost all countries are going for IR suppression. So therefore, the exhaust temperatures are coming down. So the hull, which radiates at a lower temperature, as I said, 60 degrees, it is in 8 to 14 band. So they are also becoming important. So the new missiles which are coming seekers, they are coming with dual seekers, both 3 to 5 and 8 to 14. So till now, as India also, we focused only on IR suppression, means we refer only to the exhaust. But The time will come in next couple of years when we will start working on the hull and those areas. So that is an area where we are yet to start. So therefore, the academia has a lot of role to play.
I have a question regarding the spray system. When you spray the water and it evaporates, the exhaust plume has steam, and doesn't that have an IR signature?
Yes, definitely, definitely. Steam is also one of the signatures, but if you see the atmosphere, it has got water vapor and other things already inside. So therefore, when this exhaust comes out, uh, plume is a spectral radiator because of carbon, methane, OH, water vapor. They tend to get attenuated within a distance of couple of kilometers. So the signature does not travel. We are not trying to be a Mr. India to become invisible here. We are just trying to see that the enemy missile does not detect us before 10 to 12 kilometers. The range of 10 to 12 kilometers is because once it comes within that range, then my own armament, which is there, like AK-630 or my own guns, which are there, they may become effective in bringing down the missile. Because once the missile locks on, it comes at very high speeds, 2.5 Mach and all. If it is still in the search mode, it is in much less speed. So if it doesn't detect me before it comes to say 10 kilometers or 8 kilometers, then I have a higher chance of bringing down that missile or deflecting him at least, rather than once he is in a complete lock-on mode at 50-60 kilometers and coming at 2.5 Mach, the ship stands no chance.
So these suppressions are always on, or only it's triggered?
Yes. So if you see the passive suppression, it is structural, as I told, because it is just that you are increasing the velocity and reducing, so ambient air is getting sucked in. It is 24/7 on. Whereas the water injection system is switched on only when there is a threat perception, because as I said, it is seawater, so material corrosion is likely to happen. And okay, I am evaporating the water, but what happens to the salt? The salt is likely to get deposited on the areas on the mast and other electronics, which is not good. So therefore, it is switched on only when we know that there is a threat which is likely to happen.
Thank you.
Any other doubt?
Thank you so much, sir, for delivering such an inspiring speech. I would now like to call Dr.
I would like to answer the question from your previous, which you have asked him regarding the dynamics. How will they change when the weather changes? I didn't want to tell at that point of time. You have seen all these archers firing their, during the Olympics. The wind is there. The archer is, the arrow is fixed. It has got the same kind of a pins at the end. It is up to the user. It is up to us in the Army, Navy, Air Force to decide how am I going to adjust so that for the wind and other things. He has shown that, when the headwind is there, it becomes slower. So obviously the shell is going to fall short of the enemy target. And if the tailwind is there, it is going to go ahead. And there's going to be deviation. All that is where the man comes behind the machine. It is never the machine. It's always the man behind the machine that counts.
I would now like to request our coordinators, Dr. Prem Narayan and Dr. Gaurav Gupta, to felicitate Dr. Murthy.
Thank you, sir. We now have our next speaker, Dr. Ajay K. Sahani from Optomechanical Engineering, DRDO. I would like our senior faculty, Professor Vipin Kaushik, Dr. Sanjeev Sharma, and Dr. Mahendra to please felicitate our speaker with a sapling. The topic of the talk would be recent trends in electro-optical soldiers. Dr. Sahani is presently working as a scientist Joint Director at Instruments Research and Development Establishment, IRDE, Dehradun, a lab of DRDO, Ministry of Defense. He is Group Director of Optomechanical Engineering Design Center. His areas of work include mechanical design and development of optomechanical systems at Dehradun, IRDE, responsible for mechanical design and development of various electro-optical systems for all three wings of the armed forces. I would now like Dr. Sani to please take over the gathering.
Thank you. First of all, I will thank committee team to invite me to deliver a lecture. Basically, myself, Dr. Ajay Kumar Sani. I am from IRD, Dehradun. Just after completing my BTech, I joined DRDO. And after that, I have completed my MTech and PhD from the IIT Kanpur and then later on PhD from the IIT Roorkee. And from beginning from 97 onward, I am working in the area of infrared imaging sensor. So what Dr. Murthy was telling that they are just sensing the IR signatures. Here what we are basically in DRDO is divided in number of parts, and in one of that we are dealing in the ECS cluster, that is the electronic cluster. In this our IRD, that is here at the Dehradun, is especially devoted to IR cameras. So our outline of the presentation will be like the introduction and what is the need of the surveillance, because we have to do a lot of surveillance in the border area as well as in the perimeter security, and what are the different type of surveillance devices is there, and finally we have to do the border security, and how once you will see the target from the target by the surveillance devices, then we have to finally go for the neutralization of this system. So different type of ammunitions are being developed by different agencies. Our Ordnance Factory Board and different agencies are making different type of ammunitions. So these are the different things that we are going for the surveillance and the neutralization. And finally, how we are going to marry these surveillance devices with the ammunitions. And finally, how we are going to make the electro-optical soldiers. So what are the different type of electro-optical soldiers? Now we are planning to make soldiers that no man will be there, that soldiers will be controlled from a remote station. Maybe in the future it will go for the autonomous soldier, and a group of soldiers will go for the fighting of the war. This is the building of the IRD. IRD is Instrument Research and Development Establishment. As we know that more than 50 labs of DRDO is there in India, and out of this there are 2 labs are there in Dehradun. That is, one is the IRD, that is the Instruments Research and Development Establishment, and other one is the Defense Electronics Application Laboratory. So IRD is dealing in the visual imaging. So we'll be producing cameras for our armed forces, all for Navy, Air Force, and the Army, and we'll be making the visual imaging cameras. And most important thing that in the pitch dark night also we have to see the images. So by using the IR signature of any human being or dead or live body, anything having more than 0 Kelvin temperature will emit IR. So we have to capture the IRs, and by capturing those IR signature will generate an image. So in the pitch dark night also we will be able to see the target, and up to range of the 50 kilometer we are able to see the target in the pitch dark night. And after that, once we will see the target, finally what we have to do, we have to find out what is the range of that target. So we are making the laser range finder and the laser range designator. So we will be finding out the range of the target, and this system will be mounted on some panel tilt unit, so that it will be having freedom in the azimuth and the elevation. So we have to stabilize that azimuth and elevation. And similarly, we are making payload for the different platform like aero payload and like naval system. And what Dr. Murthy was telling that they are working in the area for the NSTL. So we are having collaboration with the NSTL and PUL Cochin, so that we are developing cameras different electro-optical sensors for the ship as well as for the submarine application. And recently we are producing one submarine periscope for the Scorpion class submarine, and this has been already realized, lab evaluated, and the TOT has been handed over to the industry. So now they are going to produce a different type of submarine periscope. And if you will see the finance wise, if we are importing some submarine periscope from abroad, it is costing around 100 to 110 crore. And here by our in-house development, we are able to produce the submarine periscope in the cost of around 25 to 30 crore. So we are reducing cost by 1/3. And the most important thing that we are know how of all the periscope. The biggest problem we are facing that when we are importing any system from outside, we are not knowing inside of the system, and the maintenance is the biggest issue. So going for the indigenous system is that way very much important. So we are at IRD, we are developing different type of periscopes also. For any system, once we will take that, see the target, finally we have to neutralize it. So for neutralizing, we have to have the range. So range we have to get by this LRF, and after getting the range, we have to do the ballistic correction while firing the ammunitions. So ballistic correction will be done based on the input from the LRF. So all these are the different area, and we at IRD around more than 30-35 mechanical engineers are there. Basically, the things is like that. If any requirement from the armed forces are there, there will be QR from the armed forces, and based on that QR, the optics design will be completed. And optics and mechanical design will be our input for the mechanical designer. So we are doing all the mechanical design and and after that we have to generate the drawings. We are doing FEA and all these things at our lab, and after doing all this, we are making a prototype. So we are having a well-equipped workshop at our lab, and we are making first prototype. Once we will produce the prototype, we have to check as per the requirement whether it is fulfill our requirement or not, and after that we have to go for the trials. Sorry. Then why these cameras are required? Because we have to have the surveillance on the what is happening all around, and without surveillance anything may happen. It is just like that we are not having eye, then what will happen to us? That just we are providing the vision to the different devices to our armed forces, and this is that the border management what we are doing, that what is any moment is happening in the border area, we will be able to see by that surveillance device. This is one of the area that in the border area. Moreover, if we are talking of any perimeter like Amity there, and that we want to have a perimeter security, so it will be camera will be mounted somewhere, and it will be able to from a control station will be able to see that what is happening all around. So that is day camera is okay, but night camera, that IR signature we have to capture and we have to produce the image. Similarly, for the VIP security, that what is happening right now, that in the VIP security, if you will see on the back of the any VIP, people are having some optical target locators are there. What these OTLs are doing, that OTL will see if any site, any shooter will be see in that direction, we will be able to detect it. So OTL we are making already, it has been productionized, and already it is there with the CAPF, not with the armed forces, but our Central Armed Police Forces. These OTLs are there. So IRD is a pioneer lab in the design and development of electro-optical instruments for patrolling, observation, surveillance, land border, air border, as well as the coastal area. And these are the different equipment different like we are making UN 51 already in the 2000. We have produced UN, and already it has been inducted, and more than 50 number is already there with the Shivalik classes. Similarly, for the second one, that is the submarine. For the submarine periscope, we are making submarine periscope, and for the ICS plan, we are making the submarine periscope as well as the directly hull penetrating periscope we are making. So there are two different type of periscopes are there. One we have to, this is not the hull penetrating, it will be mounted on the top of the submarine, and the other directly it will go inside. If any power failure or anything will happen, directly you will be able to see through the optical periscope. So different type of surveillance devices that one is the day vision. Day vision is very common. That is the CCD based, AR, CMOS based cameras are already available off the shelf. But night vision camera. So night vision camera earlier II tube based image intensified tubes are there. So it will enhance the light of the light and we will be able to see in the dusk and dawn condition. We will be able to see the target. But in the dark night, we have to use the IR that we are calling it the thermal imager. And these thermal imager of different type, that is the uncooled and the cooled, because we have to cool down the temperature of the detector. So one is the cool and other was the uncooled sort of camera is there. And this is the different electromagnetic spectrum where we are working on. And the middle one that visible we are seeing that 0.4 to 0.78. It is the visual range, and beyond this, that is the IR. In IR, there are three bands. Earlier, what Captain Murthy was telling that MWIR and LWIR, we are also working in SWIR. That is the short wave. So three different zones are there where maximum transmission of IR is happening. If transmission is not there, then we will be not able to capture anything. And these cameras are a passive device. So passive device means nobody will see that if somebody is looking toward him. So whatever the temperature, due to temperature the IR is coming, that will be captured by our detectors. That may be of SWIR, MWIR or LWIR. In the border area, we are having different type of binocular periscope. We are having the different binocular having the magnification up to 20x. And this is the picture showing on the top right corner and field of view of 2 degrees. The most important system we have designed at IRD is the HSTI with the LRF. This is the HSTI, handheld thermal imager with LRF. This has been designed around 8-9 years back, and the TOT has been handed over to different industries. What exactly we are doing? We have to design it, test it, and once it will be proven, then the TOT will be transferred to the different industry. This TOT is already there with the 4-5 industries are there, and this is having a handheld device. So its weight is around 3.5 kg, and having the 5 different sensors. One is the CCD camera for the day vision, thermal camera, that is the MWIR thermal camera is there, LRF, GPS and TMC. So this has been produced number of sites. Already more than 5,000 number is there with the Indian Armed Forces and the CAPF. So these sites are already there with the our army. And this is the replacement of our LORO system, what we have already imported. Similarly, other system we have developed is the stabilized electro-optical sight, that is SEOS. And in this, what is happening that in the previous one, this is a handheld sight, but here we are putting on a pen and tilting. So it will be having freedom in the elevation and the azimuth. So if you want to see any direction remotely by a control station, we will be able to see the target in what azimuth, what elevation it is there. So it is having the 2-axis stabilization panoramically. This is having day and night, and this is also having a tracking capability. So if once a target will be finalized, it will lock the target and it will be tracked throughout up to the range. And other one is the triple S, that is the standalone compact miniaturized site. This is a very small site, this roughly of this much size, and this is suitable for different platform. In the border area, what is happening that these systems already developed, TOT has been handed over, and these are being deployed at different locations in the Ladakh and all this area. So we'll place this system, and from 10 to 15 kilometer back, we'll be able to see all every images what is happening all around. So and this is having this observation post will be having the fuel cells and the solar charging is also there. So we'll be put over there at the distance of around 15 to 20 kilometer. We'll be able to see the images. And if we are going for the wired one, it can go to up to 50 to 60 kilometer. Similarly, we have made different electro-optical payload for the UAV, unmanned air vehicle, and the aerostat. And this is the long-range optical site. Last year only we have developed this LRO. This is a 3-axis. 3-axis means it will be having freedom in the yaw, pitch, and roll, and the 5 gimbal system. And it is having the freedom of plus minus 8 degree. All these are per the requirement of the QR we have received from the arm. And having the freedom in the azimuth n into 360. So it can see all around. And for putting n into 360, that we have to put the slip ring in this case. And wherever if there is not requirement, then slip ring may be avoided. So here we are having the slip ring, and it will be having n into 360. And these all are having the different type of sensors. Similarly, the medium range that will be range of up to 20 kilometer. And this one is the optronic surveillance site. This is a very small site having the 2-axis 2 gimbal concept, having elevation of minus 20 degrees to 40 degrees. So these are the different sites we have developed at IRD, and moreover, it is now available all over India, and it is being imported from outside also. That the different sites are there. Now, what is the requirement? Basic, once you will see through the site, what is our aim? Once we will see any enemy, that now we have to neutralize it. So neutralization, we have to use the different type of ammunition. What our army are having, that beside this mortar and all these things, they are having different type of guns. One is the most important gun is the INSAS 5.56 mm, having the range of around 400 meter, and these are being used by a human being. Similarly, different type of gun is the LMG, that is a belt-fed light machine gun, and the range of around 700 meter. I am just showing the different type of gun what armed forces are having. They are having the JVPC, and now they are also having the MMG and the HMG. The MMG will be having the range of 1.8 kilometer for range. So what we are planning, that these are the different things are there, and these are the different sites and the guns are there. One, what is happening in the border area, 2 different person. One will be having the sight, other will be having the gun. They will be patrolling all along the line of sight. And once if the person having the camera will see any target, he will just communicate to the gunner that something is happening in that direction. But the gunner is not having any sight. So what he will just look around that direction and just he will fire. In this case, what is happening, that without looking into the exactly where the enemy is there, he is firing. Just wastage of ammunition and all these things. So what we are planning, in fact, around 2 years back, we have just taken a project of WHSTI. We are marrying these two, that sight and the gun are married, and these two are being controlled from a control system. So on the top, we are putting a medium machine gun. And that medium machine gun will be mounted on a pan and tilt unit. This pan and tilt unit will be having freedom in the azimuth and elevation. Other one, we are putting a camera. So and these two are being controlled from the control station. So the person who is standing in the sun, in the rain, every time he has to be there outside. Now the person will be not there. He will be sitting in some room, in some conducive environment, and he will be able to see the border area from the room itself. So now let us see that if he is having the surveillance, they can have the sector surveillance or whatever the different type of modes are there. That he will see, and once the target is there, potential target is there, and if we want to neutralize it, from here itself, he will give the command to the gun, and gun will align to that direction. In fact, these are put at the 2 different locations. So once the sight will see the target, this will be aligned to that location. Range will be calculated, but the range, there is nothing, no LRF is there on the gun. So range will be calculated from the sight, and based on this range input, what is the range from that side will be calculated, and that ballistic correction will be done in this. correction will be done in the gun PTU, and the firing will be happen. This gun, in fact, we have demonstrated after doing this. This is the photograph in the left. We have demonstrated at the border area, and the belt is having around 234 rounds, and in 40 to 50 milliseconds, one single round will come out. By a best firer, minimum round, by a single click, he will be able to fire 2 rounds. But here now we are doing electronically, so we are able to control a single round. So we are saving the ammunition also. So these two are the mounted here. Right now for the demonstration, we put at a distance of 5 meters, and we are controlling from the belt. So we have seen the target from this, and now we have given the command from there. In this way, what will happen? That we will be able to accurately engage the target, because the now manual intervention will be less. Once the target will be locked, just we have to give the fire command, and the fire will happen. Whatever the ballistic correction and all these things, that man is always behind the machine. But in this case, after the range calculation, the ballistic correction will be done and the firing will happen. By this way, we will be able to increase the operational efficiency. And this is the firing we have done at the Udhampur. And this is the target, what it is showing in this. And the target we are able to hit in the range of 3 feet by 3 feet target at the distance of 300 meters, we are able to hit the target. This is the project we have completed, and the TOT has been handed over to 4 industries. Now there is a requirement. This is based on the Northern Command requirement, but now CAPF, our border security force, BSF and the SSB and the NSC, they are in need of such type of system. So they are approaching us, and we are telling that these are the production agency from where you can directly buy it and you can utilize. While demonstrating this system, there was a requirement that because these are two different fixed locations, so enemy will be not able to see that from where a person is able to see, but he will be able to know that from which location the firing is coming. So if some fire is coming from a fixed location, obviously the opponent will also fire that location. So it was required that why not you are putting all these on a moving platform. The concept of this electro-optical soldier came from here, that we have to put both the gun as well as the sight on a platform. Initially we had thought, why not we are making a humanoid, that like myself there is a humanoid, and on top of on the head I will be putting a camera, and on my trunk portion I will be putting the gun. But making a humanoid itself is a big deal. So what we have planned, we have planned that we have taken a mobile platform on the middle one, on the in the bottom. This is the mobile platform. Mobile platform has been already developed by number of agencies. Our DRDO, R&D, that VRD, they are designing, and they have already handed over the TOT to different industry. So this is one of the ROV designed and developed by our R&D and being produced by different industries. One is the high tech in the Gurgaon itself. So on this we are mounting these two. So on this mobile platform we are mounting this gun and the camera, and it is having freedom. In the previous one having the azimuth for both, but here we are having the common azimuth, so it will be having freedom in the azimuth direction, and for the elevation we are having different HSTI and the weapon. HSTI and the weapon, and this HSTI will be having freedom of plus minus 10 degree, and this depend upon the requirement. So what will happen, we will be able to control remotely from a remote station. It will be a RF based control will be there. It will run in the different terrain, and it will what will happen that it will be able to control remotely, and we will see the target, and once target will be finalized, I will give the command to the this gun. Here what is the most important thing here, that is the recoil mitigation. The shock coming from the MMG is around 1200 to 1500 G. So we have to dissipate that shock, because any system that PTU I want to develop which should sustain 1200 to 1500 G, it is very difficult. So in between the gun and the PTU. This recoil mitigation has been realized and it has been tested. And remotely we are able to do the firing by the firing solenoid. And firing solenoid that we will just give the pulse command and we are able to fire it. So this is the one electro-optical soldier. Such different soldiers can be deployed in the different area. Like here I am showing that 4 electro-optical soldiers are there and these are being controlled from a control station. It may be a vehicle, it may be a ground bunker. From anywhere these four or any numbers can be controlled and they will be able to communicate to each other. Either we will be able to communicate from the control station to EOS and from EOS to other EOS also. So we will be able to control all these things. So these will be some sort of in the place of the army personnel. We can put such type of the electro-optical soldiers. The target is up to the firing range of 700 meter and the mobility range is up to 500 meter in the line of sight and non-line of sight it is 200 meter. So now what we are planning that we have just one realized system and when we are demonstrating at the SF-40 due to bushage and all these things it was just there was problem with the mobile platform. So mobile platform should be chosen as per the terrain. So we are just planning to have a tracked mobile platform and the wheel mobile platform and the tracked and the wheel mobile platform on the top of that will be putting these two different devices. This is the SSTI pulled one, what developed by IRD, and the other unpulled sensor, any sensor will be putting. It depends upon the range of the gun, because the SSTI range is around 2 to 2.5 kilometer, but unpulled can be selected like 1 kilometer, 1.5 kilometer, and for the different gun, different type of the sight and ammunition can be there. These are the different weapons. These can be mounted on top of that. This is how the system will look like. That this on the bottom we are not doing any R&D on this because already R&D has been done on this. On the top of that we are designing the penetrating unit, and these are the different motors, encoders, position sensors, bearings, different class of bearing. Everything we have designed. We have got it manufactured. One unit already there with us. But what we are now planning that we will be producing more number of such type of things, and we'll be doing the networking of all. Then how this the system will look like? This will be like it should be something like that. On the top of this, there will be a screen. On the screen, I will be able to see all the feed coming from the different soldiers. And from the bottom, this is the bottom portion that will be able to control all different soldiers. And here from here we can see what is the battery status, what is the everything it will be controlled from here. And how the display will be there. Here I am putting that that vehicle camera feed will be there. So these 4 vehicle camera feed will come over here, and these 4 sensor surveillance devices feed will come over here. And wherever we will be putting this is AI based also. So if there will be any change in the scene, because at same time we cannot run all 4. So at a time one soldier will command control person will run only one soldier. So if there is any change in the other, that beep will come. So based on that I will just command that one, that other soldier. Such type of we will be having the customized vehicle. In this vehicle we will be carrying all these soldiers, and the other vehicle that on the bottom one from here we will be able to control. And finally, what we are planning is still we are not done any homework that how we are going to do all these things, because our care lab is already developing some humanoid. So we are planning to develop a humanoid, and in that humanoid, that will AI enabled humanoid, and on the head portion we will be putting the camera, and the trunk portion will be putting the gun, and now it will be being controlled from a control station. And in future it may be made autonomous, but firing should be always some firing will be done by some human intervention will be there for the firing. And then we are planning that this is that if it will fall down, so automatic fall detection is there, automatic standing is there, unassisted standing is there. So all these things will be there. So this we are planning in the future that such type of soldiers will come. This is all from our side. Thank you.
Anyone, any questions?
Yeah, in here, this system, is it possible to hit a moving target or it is for a fixed target only?
It can hit a moving target, but in that case the accuracy will go down. What we are doing that in the moving target range will be varying, and based on the range we have to do the ballistic correction.
That ballistic, what is that ballistic correction?
Let us see that a target at the range of 1 kilometer. So if I want to fire, then I have to give a lift to my gun. That is the ballistic correction.
Okay, I understand. Oh, thank you.
Sir, in the continuous line of fire, once a gun is fired, its location can be not changed. Like it do not have any movement. So if the distance between the enemy and the gun is only 200 meters, so someone can throw a rocket launcher or a grenade to just destroy the whole unit.
In fact, why this 200-meter has been taken in this case, like some building, something is happening, some enemy, some terrorist is there. So by sending a human, like an HG commando, we will be sending this one. So if it will be destroyed, that is not a problem. But at least we will be able to save the person.
And sir, as you from DRDO, I have another question not related to this topic. As we seen the more number of terrorist attacks in Jammu and Kashmir from army vehicle, on the army vehicle, just 2-3 comes and fire on the windshield. So we don't have any kind of bullet for windshield in now. So does DRDO is working on something like that?
Maybe some of other DRDO lab may be working. Exactly, I don't know.
Okay, sir.
Thank you so much for your knowledgeable words, sir. I would like our senior faculty members, Professor Dr. Vipin Kaushik, Jaggi sir, and Sanjeev sir, and Manvendra sir, to please felicitate our speaker with a token of gratitude. Thank you, sir. Thank you so much, sir. I would like all the participants and all the dignitaries to please proceed to Wall Street for high tea. We'll continue the session as per schedule after high tea. Thank you.
For this keynote talk. We are delighted to welcome you for the fourth Biennial International Conference on Future Learning Aspect of Mechanical Engineering, organized by the Department of Mechanical Engineering, ACET, Ambit University, Uttar Pradesh.
Before we start with the talk, I'd request Director ACID Dr. M.K. Pandey to present the Tulsi sapling to our keynote speaker, Professor Dr. Syed Fahad Anwar, as a token of gratitude.
The topic for his keynote talk is flow-induced vibration of a square cylinder control and effect on inflow conditions. Dr. Sayed Fahad Anwar is a professor at Aligarh Muslim University. He has a teaching experience of more than 15 years and his research interest is in fluid mechanics, computational heat and fluid flow. His major research publications include Journal of Computational Physics, Physics of Fluid, Computer and Structure, International Journal of Thermal Science and Heat Transfer Engineering.
So I welcome you onto the stage to address the gathering.
So, thank you. First of all, I would like to thank the organizers, Basant and Pandeji, for giving me the opportunity to speak here and present our work. Uh, I think I was the last time I was here, it was the first conference, 2018 probably, when we started the collaboration with MET and we started getting work. So, this work which I started, which is on vortex induced vibration of a square cylinder, or for that case, many of the cases. This is a part of the fluid structure interaction code which we developed at our place, and the contributors are Professor Nadeem Asad. So these three are my PhD students who have worked on this. One has graduated, and the middle one has gone to the postdoc. The last one is yet to graduate. So this is the result which I will present from these two. Only because I have only half an hour, so I will just go on to delve into not much into that, but the starting part of the work. So yeah, so the flow-induced vibration can be divided into two parts, which we can call as vortex-induced vibration, or the the second part of this called as the galloping. So, for example, let me explain how the vortex-induced vibration come into play. Suppose there is a, so I don't know, the GIF is not playing. So this GIF is supposed to play. Can somebody help? ये GIF play नहीं हो रहा है बोर्ड पे. I'm not able to click on this one. I think it goes to the next. Any GIF play नहीं हो रहा है. So I don't know why the GIF is not playing. It is supposed to be shedding vortices from the cylinder, which will generate into a nice pattern. And this pattern of fluid shedding basically causes the rise in periodic forces. So obviously, you all know that when your structure is subjected to flow, it will always create some forces. Now this force can be periodic, can be aperiodic. So the periodic forces come into force when we have a regular kind of a vortex shedding cycle. And this regular vortex shedding cycle gives you a lift, drag, or movement like in a time-wise manner. Nice periodic forces. Now, if this forces are periodic, and if you now allow the cylinder to rotate freely, so like if you are not holding the suppose this is a cylinder and you are not holding the cylinder, you're allowing this to move freely. So this will create like a flow like this. The cylinder starts to oscillate itself, and because of this periodic vortex shedding. So now this force, this type of flow is basically called as the vortex induced vibration. Now this vortex induced vibration, and now this is colors subdivided. So so the galloping, and there are two types of parts: flow induced vibration and vortex induced vibration. The galloping. The galloping is nothing but another form of vibration of a bluff body, but the force, slight force can cause a steady rise in vibrational amplitude. Okay, so that is what the galloping is. Now, this all started with this 1940s disaster, and I would just call as the most very well-known disaster, which is called as the Oklahoma Narrow Bridge. So it was anchored in US, and this is the you don't have a point. So this is like the Oklahoma Narrow Bridge. The picture of this. This was the invite to people to come and see the bridge. So after what happened, then you have to put inside this. Yeah. So this narrow bridge, this is the narrow bridge it is proposed, and it fell like this. If I can play this video, if you, it allows me. So see the आ रहा है इसमें तो आ रहा है उसमें नहीं आ रहा ओके यहाँ पे कुछ नहीं आ रहा so this bridge you can see that it will fall and it's not like that those people didn't anticipate this type of thing will happen so they tried lots of wires and cables to ground this but when the analysis was done after just 5 hours of the analysis it fell down okay just like a huge vibrations which came across and the bridge fall down. Now this was one example of the disaster, but we also use this to control the flow also, right? Like there is a Burj Khalifa. This is an example of Burj Khalifa building. It's a very tall, as you know that it's a very tall bridge. But at the top of this bridge, there are wires. There are wires being put to basically suppress this vortex induced vibration. So that is the whole idea, so that it doesn't make it this fall also. Now there is another example of a vortex. Some people were talking like day before yesterday to have the energy from ocean to this. So if you were to have a rig, this moving line is again subjected to ocean currents, and the ocean currents means flow current and a bluff body like a pipe which will be exposed to that. Now there will be lots of vibration about that. Now another example is the riser tube, bridge, skyscrapers. Another is the heat. Now we have started to use this also. Now this is an example of how the application is. This vortex induced vibration is being used. So this is an example of a wind turbine, bladeless wind turbine. Not there is no blade inside it. Like you know the wind turbines have blades and the whole propeller thing goes on. But it is an example of a bladeless wind turbine. There is no blade, just a simple structure which vibrates. and it vibrates, it produces energy. Now this is in air, this is in water. So it's called a very clean technology. Just you put some nice structures inside air and inside the water, and you're getting free energy. Not much of a destruction, not much of a coral destruction, not much of the carbon footprints you can call. So these are some just simple examples of this. Now let's go on to see what are the more things. So these vortex cylinders generate patterns of flow, and that patterns are important to gauge what type of vibrational amplitudes can we get. Okay, so this is called as the 2S mode of shedding, synchronized vortex. So one vortex is shed from the top, one vortex is shed from the bottom. The if you modify this 2S slightly, so it's not staggered, it's not a continuous line, but it's staggered upper and this. So this creates an induced drag, or sometimes the fishes. Fishes have, you say that the fishes have sometimes a thrust produced in this. What they do is that they this vortex treats upwards and down. If we're in a normal block body, the clockwise vortex is upstairs and the anti-clockwise is downstairs. So this one is clockwise and another. This creates an induced force on this, which creates the drag. Okay. Now, if you change this, if somehow you are able to change this configuration to clockwise and the upper layer and the anti-clockwise at the bottom, this gives a momentum deficit, which is basically causes thrust in a fish locomotion. So this type of, now if this is two pairs are from the top, then it is called as a 2P vortex shedding. If one pair is from the top, the vortex is shed, and the one is from the and the single pair is shed from the bottom, it is called 2P plus S. So these are the modes of just to get you to the parameters. So now the parameters are there. So Reynolds number, as you know, simply the all known velocity scale, length scale, and the quantities and density. Okay, now there is another thing. So if you have, the other important thing is this mass ratio. So this mass ratio is basically the mass of the fluid plus the mass of the divided by the mass of the cylinder. Okay, so the structure with the fluid mass ratio, mass. The other is the reduced velocity. It's like basically the two scales are involved in a flow. Right? One is the vibrating amplitude of the flow, and the other is the velocity and by the length. So it is basically the reduced velocity to the ratio of two scales, time scales. Now you can, if you have certain other time periods involved in the flow, like which we will going to, because it's inflow radiation. So then you have more time scales involved in this flow. So we have another which is called the Kelvin-Carpenter number. Then the Prandtl number if you have heating involved in the flow. So and the mass ratio as already discussed. Now this is the regimes of the flow of the voltage. Right. So this is called as the initial desynchronized regime. So if you increase the reduced velocity, you flow so doesn't have much of an amplitude. But if you keep on increasing, it's like increases like a linear branch. So this we call as the initial branch of vortex shedding. Now in my PPT there is there are how what kind of vortex shedding patterns comes, but somehow it is not being translated into this. So this upper branch, this is upper branch, where the highest amplitude is being recorded, or you can say that the flow is being locked in with the structural vibrations. Then you again have a lower branch. So now if you increase it further, after the maximum, it again goes on decreasing and then it goes into the desynchronized. Now this is for circular cylinder where there is a no galloping which can be found. If you have a galloping regime, what happens? If you increase the reduced velocity further, you tend to have a linear increase in vibrational amplitude. So it basically gives you the straight increase. So if you are in this regime, if your structure and velocities fell into this regime, it has a large amplitude of galloping. So this will be the place where you do not want to be, or sometimes you want to be. If you are producing energy, you want to be in obviously in a galloping regime. But if you are not producing energy, you don't want to be in the galloping. So these are some open questions which are there. I'm not going into the literature review and all those things. So what is the effect of pulsatility? So now, if you see a ocean current, it will not never be a uniform line. It's going to be changing in time, changing in space. So that we call it as a pulsatility. So what is the effect of pulsatility on the square cylinder? What are the various regimes being altered due to the pulsatility? How does galloping or the beating phenomena controlled by the variable inflow? And can we control vibrational characteristics with the help of heat? Okay. Can galloping be induced? Normally it is at high mass ratio, the galloping is induced. Can we get that at a low mass ratio? That is what the question we started with. So for this, I will again show you some simple animations. Like suppose this is a square cylinder and this is the inflow. Okay. So there's something called as an oscillatory regime, oscillatory flow. People have studied. So oscillatory flow means you are from either coming from this side or coming from this side. So either it is a plus x, flow is in the plus x direction or the minus x. People have studied only this part. They haven't studied the the same here. So if you have pulsatility, it's like more like this. You increase the flow, it is sinusoidal in nature. So these are the governing equations. As you can see, this I have written in body fitted coordinate system because I use this body fitted coordinate system for the flow. So this is like simple continuity, mass, matrix, nothing else. So this is the energy equation that we use. So no, this is the heating part with the Buznas approximation. So these are the governing equations for the structure, which can have rotation as well as, so we can have all 6 degrees of freedom. So this is the first class of flows which we have investigated. Like this is a square cylinder which is damp, or and the flow it is at a angle of attack, that is alpha naught, this is some finite angle of attack, and with certain variation in speeds. Okay, and this omega that I forget, right? So the omega is basically the variation in amplitude. So how much time has passed? So yeah, 15 minutes more than. So this is mean flow is superimposed with certain vibrational amplitude. And if I don't dimensionalize this will result into some this flow. Now, if I have a variable inflow, like this inflow is varying with time, like in here, so the inflow is varying with time. It normally occurs in a dusty environment. So this alpha t is function of time. So it's very simple model which we have written. Is that we included the sign alpha t, which is a function of time. And alpha t can be varied like this. So if you have omega, this omega alpha t alpha max is 0 or omega is 0. So then this is just a simple angle of this part goes to 0, and you have a flow which is angle inclined at a certain initial angle. Okay. Now, so same equation can work with the same model can work with both of them. So this is the normal grid generation techniques and all those. So I'm not going into detail. So this is the grid independence, domain independence, validation. So validation, I will just show. You can see that we are having a decent enough validation and with lots of data. So this is for VIV case. You can see that we have bang on good validation with the produced data, the latest to 2021. So this is for another vibration amplitude for a square cylinder. So we did it with lots of people. So you can see that it's a very good validation. So now uniform flow. So you can see that this is the regime map which I was talking about. You can see that this is the initial branch. So the validation as on the x-axis we have you reduce, and on the y-axis we have the frequency. So if the frequency becomes near to one, we will have the lock-in regime. So if you see over here, the amplitude rises. The amplitude rises. So the lock-in regime is going to be very few from here to here. This is the initial branch and this is the lower branch. Then you get a desynchronization. In the initial branch, the vortex shading pattern looks like this. Normal vortex shading pattern. But in the lock-in regime, it is slightly staggered more staggered. Otherwise, in here, in the desynchronized part, it is again looks like the original part of the branch. Vortex shading regime. Now, if I increase the temperature of the flow, so we found that this is a map of a critical regime map. So this is RIC is where the vortex shading was suppressed. What I did was I tried to run the flow with slightly increased point, stepwise increase in Richardson number. So this gave me the point where the this suppression of vortex shading took place. So the suppression of vortex shading, when the point of suppression of vortex shading, you see that there is no normal, like if you will see from here, there is an organized kind of a vortex shading pattern. Now, but this organized vortex shading pattern has gone into changed into two lobes. One is attached to the bottom of the cylinder, and the other is attached to the top of the cylinder. Okay, so that is how this gives. Yes, so all of the part is Yeah, we found that at the critical rejection number, so the flow has basically to come into the original steady state mode where the vortex shading vortices are of the similar size and they are symmetric in nature. So I tried into what basically has caused this. So I tried to write down the vorticity transport equation for this, which is equation 4.4. And from this, if you will see that the only term which produces the vorticity is basically this at the start. So it is basically del theta by del x part which basically produces that. So if you go on to this, so now I have tried to see that if the vortices are symmetric in nature, if we have symmetric vortices, if I am able to produce a symmetric vorticity field, then they will always be there will be not be any there will not be any shedding of that. So if I am able to get a temperature field which produces a symmetric vortex field, so I try to this is the direction S and this is direction N. This is normal to the surface and this is normal to the surface and then the streamwise direction. ठीक है आवाज आ रही होगी नहीं आ रही सर ऑनलाइन रिकॉर्डिंग में आवाज नहीं आ रही है अच्छा ओके ओके सो so if you have a cylinder, so this is basically the positive vorticity and this is the negative vorticity. So now if I try to plot the this with the different S values at the different streamwise part here, like here, well, for here, and with the for the different well, for this derivation, you can see that the at 7 at the vorticity 6 at the u reduce 6, which is this pink line. The pink line behaves at a very different way. Otherwise, they all are the same. This pink line is basically the line for the pink is the corresponds to the u reduce of 6, which is the lock-in phenomena. That is where the whole vorticity production basically starts. So now if I go on to the other part, which since of the gravity of time, I'm not showing the whole picture about that. So for the pulsatile flows, we have this Kc's increase from 10, 20, but we fix the amplitudes. Again, we try to investigate this in the water, and U reduce was taken from 3 to 25, and the flow approach angle, which has the reference to the gravity vector, is from 0 to 45 degree and then to 90 degree. Now let us see what happens over there. So these are quite a few, lot of them, okay. So these are the instantaneous vorticity contours for U reduced 3, and this is for U reduced 5. So U reduced 5 shows the highest amplitude of vibration characteristics, and you can see that there is a long similar kind of a structures which are there for all of them. So here, but this is structure has changes from 2p to S and from 2S to 2p, and this is all because the angle of approach is different, has been varied. So if I go on to increase more so you reduce, if I increase it for you reduce 6, so here you can see that for different alphas, these are approach angles for different approach angles, and the Kc has been varied from this is for the 10, 20, and this is 30, 40. But then again from 10, 20, 40 for the different alpha, 45 degree. This is for 0 degree, this is for 35 degree, 45 degree, 15 degrees, this is 30 and this is 45. You can see that as the approach angle is different, the flow characteristics all changes from different. And this is for U reduce 6, 5, and this is for U reduce 7. So this is another of our work which I wanted to show. So I'm just going in hurriedly because of the brevity of time. So this is for variable alpha. So alpha is now a function of time. At that place, it was not a function of time. So So important thing which I wanted to show you this, that since sometimes the sometimes the flow basically aligns with this. So you can see that at low mass ratio, which I am talking about. So my mass ratio is only 2. Okay, but I am at 2. I am getting this amplitude to rise like this. It's like the galloping phenomena. So this happens because the flow starts to align with the frequency of the inflow, pulsatile flow. So it has started to align with the frequency from the inflow velocities. So that is why this galloping is coming. And you can see this the lock-in regime. So this is our lock-in regime for the AX, and if you calculate Y, this is, you can see that the 0.9 to 1.1, we take this as the lock-in part, and you can see that you can increase the lock-in part regime from 5 to 7. So this is at alpha 90 to transverse vibration. So again, so you can see that the vortex strength, so this is the comparison of the formation length, vortex strength, and for different KCs. Then you can see that they all increase, and here the vorticity production is also large, vortex formation length is also large, and this is the range for the galloping part, and which is much more larger than the lock-in part. So you can see more of the same phenomena. Again, you see the similar structures, and this has more prominence at alpha 15 degrees. So this is, so if you have a asymmetry in the flow field, so then that basically creates the galloping part. So if you increase more, you can see that the flow is directly aligning itself with the inflow from here also. So this is F naught. F naught is the vortex shading frequency, and Fn is the natural frequency of vibration. So it has de-aligned with the flow vibration frequency. See, but natural frequency of vibration. But for F naught over Fn at 0.5. But if you will go on to see this at 1.0 or 1.5, it has now aligned with the inflow frequency for much larger times. So so these are the works which we have published in different journals from this work which I have presented. And if you want to see in detail these, then it will be easier for you. So thank you. And if you have any queries, please ask. And I also want you to invite you to FMFP 2024, which is at AMU, and please submit papers, and we are organizing that. So
Very insightful presentation. Just curious, like the bridge collapse which you showed in the second slide or something, how we can prevent it, such complex structure? Do we carry out CFD analysis?
now the fluid structure interaction has risen to a very good level.
Okay.
And you can just simulate, not in academic places, but the companies which are doing it. You can simulate all the fluid structure interaction problems. So I happened to see one of the Choi. He is one of the leading fluid structure interaction person. 2022, I met him at Roorkee, and he showed the whole this Tacoma bridge simulation. But obviously, it takes time, and because you are simulating the whole of the bridge, suspensions, sections, so very difficult job.
Getting hold of the boundary conditions also would be quite challenging.
It be easy. The problem is the computer simulations, and there is a structure interaction now. So the structures are of different types. Fluid is only of similar type. Structure, like ropes are there. The ropes have different flexibility, different kind of internal material. Then there will be steel wires. So steel wires have different type of structures. Then you have the pavements. So that's where you walk. That has a different kind of a structure. So all the structural materials. So the K, the structural part, if you go into the K is not as simple as that. So it has lots of geometric material non-linear independent. So it's a very tough kind of problems to simulate.
Any other questions? Right. Thank you, sir, for such a beautiful session. It was extremely insightful for all of us. I'd now like to invite Dr. J.M. Giri, Professor and Head, Lloyd Institute of Technology, Greater Noida, and Dr. Navneet Kumar, Professor, Motihari Engineering College, Bihar, to kindly felicitate our guest, Dr. Syed Ahmed. Thank you. We'll be moving on with the next key talk session. We have the session chairs, Professor Dr. Jitendra Mohan Giri, a professor at the Lloyd Institute of Engineering and Technology, Greater Noida. Dr. Giri has substantial and significant academic experience with an approach to drive tangible results, a reviewer for many prestigious international journals, and fellow of Institutions of Engineers India. He works with a diverse range, including teaching, controlling examinations, and event planning and coordination. He has been instrumental in arranging and coordinating technical and non-technical events, such as national conferences and workshops. The next session chair is Professor Dr. Navneet Kumar, a professor who has been a part of Motihari Engineering College since a very long time. I'd like to welcome both of you also. Thank you so much for coming, taking out your time and attending the event. I now request Professor Dr. Navneet Kumar and Dr. Jitendra Mohan Giri, along with our faculty coordinators, Dr. R.K. Tyagi and Dr. Sanjeev Kumar, to present a Tulsi sapling to Shobna ma'am as a token of gratitude. Thank you.
Topic of the keynote talk is hydraulic modeling of water distribution network for operational excellence in water management. Dr. Shobna Singh is an assistant professor in the Department of Mechanical Engineering at IIT Jodhpur. She holds a PhD in solar thermal systems from IIT Delhi and has more than 12 years of research experience, including working at Arizona State University, USA, and Aalborg University, Denmark. She has co-authored more than 60 scientific publications in high impact journal articles and book series. She is currently leading the Energy Conversion and Storage Research Lab in Department of Mechanical Engineering at IIT Jodhpur with a focus on engineering conversion technologies, energy system analysis and integration, hydraulic modeling, multiphysics simulations. Her recent work involves the demonstration of a smart water supply grid for operational excellence in water distribution network, contributing towards sustainable development goals. I welcome you, ma'am.
Well, thank you. Thank you for such a good introduction. And before I begin, good evening, everyone. I would like to thank the Professor Vasant ji, of course, and the entire organizing committee for conducting such a wonderful conference, calling so many people all over the world, and having so many diverse topics in this session, which enriches, of course, anyone's knowledge bank, I would say, such as mine. So here today I am present to talk about hydraulic modeling of water distribution network for operational excellence in water management. As my introduction said, I am assistant professor at Department of Mechanical Engineering, IIT Jodhpur. Typically, I am a thermal engineer. I work on wide range of thermal energy systems and optimizing those designs for different operational and applications. But actually, from past 2 years, I have also been introduced to water energy nexus and the arising problem with the water distribution systems due to water being a very important entity to our lives. So I actually dived into this work and I found that this could also be of interest to a lot of young researchers and students, of course, from mechanical department to explore it as their area of domain in future. So this is the slide where I would be walking you through all these topics. I would first give you a background so that the audience can set the relationship between the topic I'm going to talk about with the sustainable development and how it is important, and also became a motivation for us to carry out this work which I will be presenting. Then I will be introducing what the system is and then what the hydraulic model represents for the system, its applications. And then I'll also present the case study that we did at IIT Jodhpur campus, deploying this technology and hydraulic model for our system for operational management of water in our campus itself, which model can also be replicated for future different cities and different communities. So yeah, just as I said, I would first like to set a relationship between water and its role in the sustainable development. As we all know, water is very important. It's a vital natural element in everyone's life, right? It is very needed for the development and sustainability of the environment. Just because you all know, either directly or indirectly, we all need water in the processing or in number of applications. We might not just realize it, but it has a very critical role. Therefore, the reliable water supply, we can say, that impacts several aspects of human lives like water consumption, energy generation, agriculture, and environment. As I said, because it's used directly or indirectly in a lot of processes. Therefore, it's very imperative that a perfect balance between the water resources and the supply should be maintained in order to meet the demand, water demand. However, due to definitely rapid urbanization, increasing pollution, improper use of waters, and of course, leakages from the existing water systems, this problem has become or arise, and scarcity has been arising in our country, in fact, across the globe. I will talk about how serious the problem is from these numbers that you all see from the bottom of these slides. If I just talk about the world, approximately, according to the report from ESRI Institute, which is the latest report as well from, I would say, published in 2022, they say that 1/5% of the world's population lives under the conditions of water scarcity. So just for those of you who may not be able to technically understand, it is just like there is a lot of a demand, huge demand for water, but less supply of it. So those areas can be considered as water scarce areas across the world. And the number is astonishing. And if I talk about India itself, we are no different. Of course, we also have water scarcity problem arising in India. Approximately 55% of Indians faces high to extremely high rates of water scarcity. That is also coming from the latest report of themselves. And if I count it in terms of population, approximately 62.47 million people in India still do not have access to improved water sources. That doesn't mean that they do not have water resource. They do have water resource, but they do not have it in a portable form or in a portable manner that they can be utilizing for the daily household chores. And again, India scores only 56.6% in terms of attaining their sustainable development goal, particularly talking about the sustainable goal number 6, which is basically nothing to save water and water for all particularly. So if I talk about, there are quantitative numbers and matrices which every country has to furnish to the United Nations in order to say where they are in order to achieve these sub goals under every sustainable goal. And we are just reaching 56.6. So there is a long way to go, long road to go. And while I would not also criticize our government is trying really hard. If you just know about number of national missions, Jal Jeevan Mission, Har Ghar Jal, all are the government's initiative that they have been taking in order to reach this goal which they have set, which is very ambitious, I must add, especially for a country like India, right? But in addition to these goals, what is important for us as engineers to recognize where the problem lies. So the primary problem we looked at, I'm not saying that there are not other many issues. There are many issues which are contributing to these, numbers that you are just seeing. Improper practices, lack of awareness, right? Losses, water losses from the systems, as I said. And then there is no policy in order to correct those things. So what we realize is in the water distribution systems, these are the system. In fact, in the next slide, I'll talk about it, what water distribution systems are. But basically in these systems, especially the conventional ones, which are already in place in all the cities, in the communities, in campuses, they are pretty old. They are even 50 years old. They have not been upgraded. So what is happening, either the pipelines are so much actually rusting off that they are not able to deliver efficient water at a required pressure, or there are other challenges associated with it. So recognizing those challenges, one need to actually address that. First, you actually can upgrade those water distribution networks, try to understand their performance, and then maybe do the operational management appropriately. So this is what the inline I would say I would be presenting next. Just again to set the tone of the presentation for those who might not be aware what distribution systems I'm referring here. Water distribution systems are the systems, these are the network of pipes that transfers water from source. It could be source, direct source, or either a treatment facility via network of pipes, and a supply water to the final distribution point. In some cases, it could be communal, that they would be just supplying to the main distribution line of a community, or they could also be supplying water to the taps of each household. However, these systems require energy to supply water. So definitely, depending on what system you are dealing with, there are different means of supplying water using energy like gravity or as well as pumps. So here I am showing a very typical distribution, an example of a water distribution system. You can clearly see there are network of pipes that are connecting different households, and water can be supplied from a source to these households. And typical components which each of these water distribution carries are the storage tanks, walls to supply water, to carry water, as well as pipes, of course, of different diameters just to fulfill the demand of a certain area of a household. So these are the water distribution systems, and the problems associated with are could be the leakages, improper management, no prehistoric data which could tell you how the efficiency of these systems are. Is there any need required to change all this? So in order to understand how these are behaving, how they are performing, one needs to develop a replica of it, a hydraulic model of it. Now, this hydraulic model in typical words can also be called digital model of these water distribution systems. So what I'm going to show you next is the hydraulic model framework for these water distribution systems. It will give you a very good idea that what it entails typically when it comes to developing an hydraulic model for understanding the working behavior of these distribution networks. So clearly, in order to develop a data, we require lot of information. Information in terms of topographic information, where the water distribution system lies, how many loops are there, how many pipes are there, how many walls are there, and then how do we operate. It depends, of course, based on the scale as well, if we are dealing with the small water distribution networks or large size distribution networks. So all this information would come in and contribute to the modeling framework, which I will also be presenting one step at a time following to this slide. And of course, not only that, you also need billing information. What is the actual demand for water actually which is given by the residents inside the community or anything, wherever these waters is being supplied. Production information, what energy is being consumed by for pumping that water, many other information. In addition to that, sometimes how do we deal with any scenario in these water distribution system? How do we typically operate? And that varies based on the residents, based on the water users. If it is an industrial setup, definitely the demands and the operational setup is different than compared to whatever it is for a district, whatever it could be for a educational institute like IIT Jodhpur, which I will be presenting next as a case study for ourselves. So all of that data will actually to be fed into the modeling database, which will actually depict the actual scenario of a water distribution system one will like to model. And once the model is developed, which is hydraulic models, of course, there are governing equations for the hydraulic part. And then if you're simulating quality as well, then the transport properties shall also be simulated. However, I'm not going to focus into the mathematical aspect and show you all the equation because it's a keynote lecture. Probably students who are interested, they can reach us out later on. But once the model is set up, it's very important to calibrate it in order to trust your model and its level of accuracy. Definitely, you can do it two ways. You could actually reach a very higher detail by utilizing GIS data and actually do not miss any single thing. However, it could also be simplified. So we will actually also tell you that how you can simplify the model without losing critical information and without losing the actual behavior of the water distribution system. And calibration is very important to do so. You will require real field data to calibrate your simulated results coming out of the model and see whether they are in agreement with one another or no. If they are not, you may have to fine tune your model in order to depict the actual behavior of that system, which is being depicted by the field data. So after once you do that, you can carry out your analysis. And now what type of analysis I'm referring? This analysis which will help you attain operational management excellence into the system. You can best utilize your energy resources, best utilize your water resources, even if they are even limited. So that will give you a tool, a powerful tool to basically best utilize the resources you have, energy as well as water resources both. What type of analysis one can do? I hope you are all able to read because it's not very clear. Steady state analysis, extended period simulations for a seasonal pattern of demand and utilization of water across the network. That is also possible. Water quality analysis, because one would like to know if there are any contaminants into the system. How do these contaminants transport across the distribution system so that the corrective measurements could be taken by the operational authority and utilities in order to mitigate those. Transient analysis are possible even. So you would able to see any change in the dynamic scenario, weather changes, calamities changes, anything, or even infrastructural changes, which could be possible over a period of a time. All those kind of long period transient analysis could also be carried out, and tank mixing analysis is one. However, I must add here, these are not the only analysis one can carry out. There are numerous possibilities nowadays. You come up with a goal and you have that served by your hydraulic model. Definitely, these have to be set up prior to define your inputs for your model. So this is something, a basic infrastructure and example for the modeling process one can go through in order to set a proper hydraulic model. Next, I'm going to talk about what hydraulic modeling softwares there are available. Especially this is the slide I kept for the students so that they should know that need not to worry about the writing a code themselves like a Hardy-Cross method. There are very nice tools already available across the globe. Some are commercial, some are freeware. I would recommend go for freewares. It will save you a lot of cost and it will also make you understand the underlying equation, because sometimes commercial software won't let you see what is in the black box. So this is something my recommendation to students. So some of the main ones I have listed, these are not the only ones, there are many more, but these ones are the ones which we also reviewed prior to start our work. WaterGem is a commercial one. It is also very expendable in terms of if you have a GIS data, you want to include fine details into the system. You don't want to miss even a tiny pipe into the network. You don't want to miss a single wall or any diameter. Then the GIS would give you, the integration of GIS with WaterGems will give you that flexibility. Moving on, WaterCAD is also a commercial software. Second is PipeFlow, which is also commercial. Synergy Water, H2O Net, H2O Map. These are also together can be integrated in a one platform. IPANET is also the best one, which is also developed by, Environmental Protection Agency USA. So they developed this and they made it free in a public domain for use and for distribution. So why not benefit from this resource? And it has also been widely used across the globe and has been validated, calibrated nicely, and has shown potential in studying the water distribution network. And it is free. First of all, the prime thing that any student would like to know, do I have to spend money even to just learn something? No, you can't. You can just simply pick it up and you will be good to go. Branch is also a freeware. Hydraulic CAD is also freeware. Some of these have an integration to, combine both tools if you want to even increase the potential of, doing modeling and analysis part. This flow chart here is just to depict the steps, which I will later be also presenting in the slide, that how you can actually take steps and reach the final analysis goal, whatever it could be for your project. So I'm not going to walk this through, but I will be first talking about the applications. Now, people might wonder, why do I need hydraulic modeling? Maybe it's a job of a utility. Why do I care? But I think we must care from the very first slide of mine. If you really do care about the future generation and even yourself, then you must really encourage people to look into this and try to contribute in order to save water, conserve water, and deal with whatever is present to you, available to you, rather than demanding more. So hydraulic model could help you understand leakage detection. So it will, through the modeling part, you will be able to know whether there is any leakage inside your network. Pressure zone management. This will help enable to suffice the required demand at a required time at a particular zone. Especially, I can take a case of IIT Jodhpur campus. Maybe I'll explain later in that part. We have students living in a certain area with a higher demand of water than any other resident. So we have to do this management. They would always have water at a sufficiently adequate pressure so that they will have their requirements fulfilled at any time of the day. So that you will only be able to do once you know how much water they are needing. One can also answer back to me saying that we can put up water meters, but water meters are going to just tell you how much you used. It will never help you doing anything else. Probably you can do the anthropological measures. You can restrict yourself intentionally. Oh, I'm not going to take bath today, probably, and not waste any more water. But this is not it is. Utility has a responsibility in addition to the people like ourselves to handle that water which is coming from the resource. So that is also possible with the help of hydraulic modeling. Let me tell you, it's a very powerful tool. You can say that through these points that it can furnish multiple goals of anybody in any kind of a region as well. Demand forecasting. If there is a development in the region, how will the demand go, and then how can you manage the water in that scenario can also be, learned from these hydraulic models. Renewable energy integration. Now government is pushing everyone to utilize renewables, right, and to become energy self-reliant. So this is also one of the scope that one can use and integrate energy rather and reducing the pump energy and power that a system is using. Pump scheduling, again, this will ensure that someone in a zone is getting water at a sufficient pressure at the time of requirement. So you can schedule the pump. Typically, we practice this in IIT Jodhpur. We turn off the water supply after 12 o'clock at the night time till 4 a.m. in the morning. Because typically we believe that whatever is reserved in the tanks inside the building shall suffice the water supply during the night period. Otherwise, pump need not to run 24/7 and waste energy without any demand. So all these things can also be taken up by any community and utility once they see what is going on. Emergency responses can also be addressed using hydraulic modeling, so as energy efficiency analysis, and if you are planning to expand your infrastructure, your institution, your district, then you can use hydraulic modeling as a tool and do the decision making in that process as well. So again, just coming back on understanding what hydraulic models are, what are their applications. Now I'm coming to the interesting part without diving deep into the physics and mathematics, but walk you through the case that we handle at IIT Jodhpur. We developed smart water supply grid at IIT Jodhpur by deploying smart sensors. So here I'm presenting the case study where you can see in this map, this is the IIT Jodhpur campus. We have 3 pockets which are distributed across this national highway that goes to Nagaur city on the north side. So you can see that this pocket A is the biggest, and this is also where the academic and administrative and residential areas are lying. This is the technology park in the pocket B, and C is something for the guests. So what I mean is this, which you see is spreading over here. This is the map of water distribution network. Not just all water distribution network. The very best part about our campus is that we have graded water supply. We have 6 pipelines for different grades of water, which will ensure that there is no potential mixing of contaminated water from one another. So we have different grades being supplied from different pipelines. Here in this project, especially for today's talk, I am keeping domestic water supply distribution line in focus. Rest of them I'm not discussing. They are flush supply lines, fire flow supply lines, irrigation pipelines we have, many others we have, right? So in total we have 6. But because the drinking water and domestic potable water requirement is the highest, I'm referring that case today. So what you see here is the distribution pipelines, which are kind of, I don't know if you are able to see the colors. The light green color line, which is this one, is depicting the transmission line, which is kind of a shoe sole shaped ring over here, right? And branching out are the sub distribution lines, which are shown by the other lighter color. So basically, these are the sub lines. There is a main transmission line supplying the water from the source pumping station, I mean. And what we felt is that whatever we were feeding in per day, it is of 1 million liter capacity. There is no demand of that much amount of water, but then it is where it is going. So that risen a question in our heads, and we started modeling it. Simple mass balance. Whatever is coming in, where is it going? We need to account, and we need to check if there is any leakages in the system, which we are not aware of. And the another thing is, we do not have underground pipelines like typical infrastructures have. We have tunnels laid across the entire campus, and through those tunnels, these pipelines are going, which will also enable us. In fact, it was fortunate enough for us so that we can do the physical inspection and figure out what is going on, if there is any problem with the pipelines or with the walls, or where we want to place the sensors as well. So in this project, it occurred in 2 phases. The very first phase was to understand the system, do the physical visits, and try to figure out with the infrastructure department of our institution to see what are the problems. So the challenges at that time when we began this problem was that there was no specified district metered area. District metered areas are the regions in the distribution network where the demands vary from one another, and they are being supplied from one single subdivision line. So that way it will give you the inflow to the water, and that inflow will be distributed among different branches and buildings, and then there will be dead ends. So in the beginning, we didn't have any specified region. In the project, we did. Inadequate data management and unavailability of historic data. There were manual records on pages. There was no automated system to keep the record of water distribution and the supply and what we are receiving from PHED, meaning municipality. And then we had manual water quality monitoring. People would go to the water treatment plant, took the samples, and then they would sample it out. I mean, they would be keeping a report, but it's definitely not efficient for anyone to see and take measures in a timely manner, I would add up. So limited flow meters were there. They know how much is coming. They know at certain places where it is going. However, they cannot keep track for different type of users, whether they need this much amount or we are simply just supplying them without controlling it. So manual control was there, and many other issues, as I had already, leakage issues were there, access and unmetered water consumption was there. We were believing that there were some commercial places where there is unmetered water consumption occurring, and many other intermittent supply problems were there. And with the increasing strength, again, the water demand was rising, and we had only a capacity of 1 million liter per day. So we have to work with what we had. So that gave us motivation. Then what we did, we deploy smart sensors across the network strategically by using an optimization strategy. As I said, we had 6 grades of water: domestic, irrigation, fire hazard, soft water for centralized air conditioning, water flushing, and sump drain. This water network basically serves approximately 352 hectares, around 850 acres, I would add, right? And the entire main distribution line would add up to being 13 kilometers. So you can imagine that within that area, we have to find optimal way to utilize the available water that we have. And the line is actually serving 5,500 people, which is floating number, I would say, because we have a lot of students living outside the campus as well. In entirety, the network had 1,100 nodes approximately. Nodes meaning where the pipes meet one another and water is being divided into different zones. So we deployed 10 smart ultrasonic flow meters at strategic places where we divided district metered areas. So you may be able to see these asterisks in the blue color that I pointed out in the water distribution network with the some glimpse. So these are the pipelines going inside the tunnels which are distributing, and there are different pipes for different grades for water being distributed. And then this is the water treatment plant that we have. We have deployed quality sensors, which actually monitor 5 different now. I have to update this: pH, chlorine, TDS, temperature, as well as now we are also adding some biomaterial, capturing sensors as well. And they monitor water pressure and flow rate 24/7 online. So I'll show you. We developed this. So this is just a glimpse I kept in a slide so that you will be able to see a bird's eye view what it looks like. So these are a couple of locations, although these are not all. In total, we have 11. But here, this is the quality node at a water treatment plant. These are what I'm talking about, the district metered area. These are the hostel buildings for students, and these are the inflow lines where we kept sensors so that we could monitor the aggregate amount of water which is being supplied to the 11 or 19 hostel students buildings. And here in this picture, you might be able to see the ultrasonic flow sensor that is deployed, right? So that is deployed on the pipeline, and this is the over the ground unit where you will be able to see the water meter, the Wi-Fi router, and the RTO unit, which actually transmits the data to the cloud and to the server, where which we can analyze. Yes. And the very last one is for the quality monitoring, which is deployed at the water treatment plant. And what I'm trying to say that we get 24/7 data per minute, which enable us to see if there is any anomaly, what is the actual water consumption going into that line, and we will be able to determine whatever water came from the PHED is being utilized in what manner, in what amount in different district metered areas. It is also equipped with alert generating system. So if there is anything going wrong, especially if I take an example of quality, if pH goes beyond the recommended limits from WHO, then it gives you a SMS, an alert. It comes to my phone, which tells us that, oh, something is wrong, and one would go over there, check the quality, and do the chlorination or anything else which is required to bring the number down into the required drinkable limit. So hydraulic model structure that we developed for this network, we used IPANET version 2.2. This is simply a framework which you can see. We use the network, we converted into the IPANET compatible file, IPANET. And then what we did is we created a hydraulic model to it by supplying the number of data which I was referring earlier. And then we use the sensor data, which is the real-time data, to calibrate our model so that it will depict the actual behavior of the system. So all these steps you will find I'm talking one by one. So I'll just browse through these slides because time is already over. So first you have to create, this is for students in particular, that what you have to do step by step, that you have to first develop a topology which requires number of data sets. So we received a CAD file from the Office of Infrastructure. We converted it into a readable file and then used it to actually made it IPANET compatible using, again, freewares. So everything is available free. You will be able to do it. And this is how it would look like. However, there were limitations because the map was old, lot of pipes were not there, lot of nodes were not there, and we also did not want many details which were absurd to us. They were not useful. So what we did in the next step, we skeletonized the network. We reduced the network, we actually reduced the nodes which are either not useful, although they were on ground but are not supplying water, they are meaningless. So this way you can simplify your model and just make your work even easier. And then we updated our model. While we were building this model work, 2 new hostel buildings came up. So we have to upgrade the pipelines. So you can do the upgradation manually as well, which your model allows. So that is also shown. Okay, these are simply the numbers of the network. How many nodes are there? Nodes are nothing but the junctions of pipes. how many pipes are there in the final network we had, and then we work with it. Now, once you have the network model ready, you have to give it the base demands. Base demands is the typical water amount which is required by a certain group of people. You simply calculated how many people are living in a building and divide it with the standard number of consumption. So we did that, and these are two random examples, one taken from the hostel building, one from the faculty apartments. You provide these as a demand at certain nodes, which will drive the flow. So this is something, it's a demand driven model, you can say that. So once you give a demand, it will simulate the flow and pressure accordingly. So now once you run it, once you simulate the model, you will have some reports like that coming up by the model, which are pressure reports and flow rate. So these are again the flow profiles at certain node. Again, the images are not so clear probably to the audience, but I can see them. And this is something you can also see in terms of 2D layout, that where the pressures are high, where the flow was high. So you know now the pressure zones. This way you can determine the high pressure zones, low pressure zones, and then manage your network accordingly. This will tell you to enable you to best operate your network also. Next slide would be, as I said, calibration is done required. So we also used our real-time data received from the sensors, and we calibrated our model. So the data gave us these type of varied demand patterns. These are only few, but these are the type of demand pattern, and you can pay attention that every demand is different than one. So meaning how many different type of users we have in the campus, that it tells, and you provide that to the different nodes. It will again simulate your model and give you basically a proper behavior, the actual and exact behavior of the network. These are just some calibrated results, which just simply shows that how the real-time monitored data from the sensors is matching with the simulated data, which tells you that your model can be trusted, utility can use it to make decisions and manage the water efficiently. This is just, again, I'm just walking through the slides now. These are the flow and pressure analysis that one can do with these models. This is simply the monthly patterns. You can actually see where the spikes are there. Maybe the water, it's because of the water hammer effect. When you turn on the pump, it simply hits the sensor and you will have a spikes. And simply corresponding pressure demands you can see. So lot can be understood about your system simply by developing a model. Quality analysis one can do. We also did. So we actually mapped out flow as well as pH and temperature across the water network. And you are able to see that whether they are in the allowable range, which should be for a potable water supply. And they are. So that way you will be able to monitor more your water distribution network and keep an eye. Anomaly detection. One can do anomaly detection also with the data. I'm not going to talk about it. If anyone is interested, they can reach me out later. Future work, I just want to say now, this hydraulic model will enable us to develop digital twin of our campus water distribution network. And it will enable real-time control and monitoring of the network as well as manage it remotely through IoT. So this is what we are developing now. In fact, the model is already there, it's calibrated. Now simply we are using Python-based digital twin framework, which I'm just trying to depict. We are working on it right now. One paper is already communicated. So once it is out, probably I shall share. You will be able to see that how the digital model is working. Conclusion, of course, it's just like that how important hydraulic models could be to attain operational excellency in operating water distribution networks. And please keep that in mind. Although I presented a case of IIT Jodhpur, one can do that same exercise for any scale, for smaller scale, for rural scale, for bigger picture. Even the work has been done for district level as well. So don't be hesitate. It's simply a matter that one should be interested to attain that excellency in the operation. Then definitely they will take this challenge up. So in the present work, of course, what we learned is that hydraulic models can enable us to improve performance, leak detection, attaining energy efficiency in running the systems, minimizing water wastage by better utilizing the water supply, and of course, timely decision making as well. And of course, it helps also us to tell people that, this is possible. You can also contribute by changing your practices of water usage, because they get excited when they see the technology can be brought it in their own place. When they see from their eyes the water demand being changed. So when they see what is going on, they become much more related to that and they take measures. So in the present case, it is all about IIT Jodhpur. I won't walk you through these points. This is the one which I have been talking so much already about. And I would like to conclude here my talk. If anyone has any question, are interested in knowing more, they can reach me out later as well, if not today. Thank you.
Do we have any questions?
What was the cost of the project, madam?
See, the cost only went into, as I said, in the modeling, we used freewares. So we had students, we have them work on these projects. So only the ministry have given them funds. We didn't do anything. We didn't spend any single penny. But in deploying the sensors, it costed us approximately 40 lakhs. However, we would like to have more sensor deployed in order to cover the bigger area. That might reach, this figure might reach up to 1 crore or even more, which has not been estimated because prices are changing every day. So some group is also working in developing sensors, in-house sensors, rather than having off-shelf, because the one which I deployed, they were off the shelf. I directly bought them and it took me 40 lakhs for that.
That's what, because implementing at a town scale or a village scale even will be, one is of course the original cost of the sensors itself, and second is their maintenance.
Yes.
So that would also be, because otherwise it's a very required topic India is facing, and in fact they say that water is going to be the next diamonds, like.
Right.
So it is definitely something very important, and I appreciate the work that you have done. Only thing probably now we have to, as a mechanical engineers, we have to see how to bring down the cost so that it can be really applied globally, or I mean at least India wise.
I agree with you. But there is also one uncertainty here, because depending on the scale you are working with, this cost will vary. So you can never be able to pinpoint the cost. And also with the advent of technology, prices are varying like you can imagine. And if you will find a sensor that is half a cost, if it would be made in India, because all these were imported ones. So if could be made in India, you will actually cut down the cost by 50% straight, actually, because you would also have to benefit the person who is manufacturing them. So I'm adding that up here. And then the maintenance cost would come. So yes, it is true. But as I said, within these number of sensors, we are able to do this much. So definitely it's a trade-off. If someone has to save lakhs in future, they have to invest in capital costs right now. That is true in every system. Yeah.
So indigenously, but as I said, now for the sensor manufacturing, we can't do volumes.
We can't.
So if something like this also happens, probably then he will have the volumes required for him to actually take it to the next level.
Right.
Very good work.
I agree. Thank you so much.
Ma'am, very good work and very voluminous also.
Thank you. Yeah, it is.
Another thing, just wanted to can we use it for studying groundwater depletion, which is a major problem which we are facing these days? Can we use this kind of work for understanding groundwater depletion, which is happening in a lot of places in especially northern India?
Of course, we can, but definitely then the approach would be different, because for the groundwater, you have different water sensors, especially the moisture ones typically. Even we have the same problem in Rajasthan. We have fluorides inside the ground and we have polluted water inside the city, and the water levels are anyway too low, at very big depth, I would say. So we have this issue, but then they are using GIS and other sort of historical data in order to first map that out, and then putting some sensors, moisture sensors inside the ground to monitor that ground level. Here it is something different. Here it's water and flow. Water is flowing. So I dealt with this. We have one colleague, maybe he can answer this question very easily, but we are not monitoring at a moment groundwater. But I still strongly believe, because I did come across the studies where they are using moisture sensors at a very large scale to monitor and map how the groundwater is doing, and just keep track of it and make use out of something, or there are technologies which are enriching or increasing the groundwater level. We have one faculty who is developing ceramic pots. They are digging those down inside the ground up to 1 meters, and the water percolates through them, and that way, so whenever there is a rain, they just stand by there and then it percolates very slowly to the ground and increasing the water level. So such kind of studies have been done already, where they have found that in 6 months time the water level has been risen by simply doing very sustainable technologies in use. So yeah, it can be possible, but it should be in demand whether you want to monitor. And there are studies where they are monitoring the groundwater, but just not us.
Which has the ground, so the flow or the distribution of the piping network is underground.
Yeah.
So, and I don't, like, I think probably it will be very difficult to.
It is possible. I mean, although in our case it was very convenient for us so that we could do physical inspections, but there, whoever have laid those pipelines, they have maps. Although they might be on paper, so you can digitize them, of course, and then convert them into CAD file and use it into bringing it. And utilities are doing that. Let me tell you, I have had a meeting with the Jodhpur Development Authority where they have these maps. And they in fact are using EPANET as well, but not that efficiently because they simply are using it just to enhance the city, to look at the new developed area, how the pipelines should be laid. So their goal is planning and designing the system. Rather than for us, it is more of an optimizing the system, using the water resources and make best use out of it with the energy sources. So it is possible.
Yeah, and since I have been to Jodhpur twice,
Okay.
and I saw your network.
Oh, you did?
Yeah. I saw your network, and even the stations which you were showing.
Yes.
So somebody, one of my students was there, so he showed me exactly how you have developed those sensors, and I happened.
I'm glad to hear that anyone. So yeah, I do have a video, maybe not just now on this PC. Otherwise, I could have, all of you could have been seen that bird's eye view of the sensors that we deployed at different location. It actually gives a very good feel to students, especially younger, because they would be questioning what is it, what it is doing, and we tell them these are the sensors and how they are just transmitting the data, which is so meaningful that you could work with it and do multi-ways actually.
Any last question?
Not yet, sir. We are still in the first phase of the project. As I said, the first phase was like deploying these sensors and see how the long-term monitoring and measurement can happen. Simultaneously, we are developing this modeling part as well, which we have already. And so there is an article which you can see, which is already published on the entire work of the first phase. Next phase is to utilize this data, because even if you would like to use the predictive models, I need and we need a huge amount of data which we are gathering at a moment. Once we have it, we shall be able to do life cycle.
You have done maybe experimentally. You have find out how much saving of water, like till now, as per your experiment you have done.
I'm afraid I don't have those numbers to tell you, but we have some numbers coming out of the simulation. So the Office of Infrastructure that operates in our campus, this actually they are not yet implementing this because they need it real time, which is digital twin would do for them. So right now we just only tell them in a volumetric number, oh, this much could be saved. So they are just simply using it as a best practice manner. So they are reading the data, they are just making it okay, because right now we don't have two-way control walls. So again, in the second phase, the money would be required to deploy and replace what walls we already have so that they can remotely monitor. And then probably real numbers would be shown to people. Yeah, because this is just predictive at a moment. Thank you. Any more questions? Yes.
Thank you.
Very realistic work. How have you detected the anomaly?
Anomaly, it's just like the real-time data that we had. What we did is we statistically use the Gaussian filter in MATLAB, let's say. We knew the outliers. We know how much pressure should be applied, how much the pressure should be in our network. When we look at that, and so how much the pressure should be given the cross-section of the pipeline. So using that, we determined the range, which is actually came out to be 20% up and down. Once we gave that, there were outliers beyond that range or under it. For example, you might see there were some numbers which were giving zero flow, which either is possibility if we are turning off the water supply during the midnight time, but sometime it is also appearing in the daytime when we do not shut down the supply. Then those are coming as an outliers. So we are just simply using statistical means and making use of them to determine some anomaly. Now that anomaly could have any reason. It could be physical, it could be unphysical, it could be a problem with the data, it could be a logger which is not logging the value accurately, because there is a time difference also in getting that data fed back from the server to us. a couple of minutes. Yeah.
So it's a basically time series data. So
Yeah.
the anomaly detection, is it like hourly, minute, day?
You can do it in actually any way.
No, in your experiment.
In our
Means I know-
experiment,
yeah.
in our experiment, we are doing it minute wise because we are gathering data minute wise. But sometimes I also see it's not required because hydraulics really does not change that much. So we are thinking about either taking an average overlay in half an hour or probably an hour. That will come. Yeah.
And what kind of action is taken if you detect an anomaly?
Then, of course, as I said, that our system is equipped with alert. It will send an alert. And then once that alert, right now, it's not being used fully by the OIE. It's just me as a PI. Right now, I am receiving them. So I cannot do anything much except informing the OIE that something is wrong. Please go and check. However, once it will be fully developed, it will be self-worked, automated. OIE will get a message in their own offices. And if they would have a two-way control, once the things could be replaced in the system, they did not even do it manually. But right now, they send the person over there to have a look. They check the walls. They sometimes divert the water supply also to just have a look what's underneath going on, likewise. And since we deployed this, let me tell you, before that, we had several instances of leakages which could not be detected where they were inside the ground, you can say, or inside the tunnel. But now, if you are monitoring it in a fine manner, you will be able to locate. So you can localize the location as well. Yeah.
And I think when you will integrate with digital twin, it can be real
Yes,
time.
yes, exactly. So that's where we are heading.
Okay, thank you so much.
Thank you. Thank you. Yes. So yeah, non-revenue water, we have that in the agenda as well. Yes. Thank you.
Thank you so much, ma'am, for your kind words. Now I would like Dr. Vipin Kaushik along with Dr. Sumit Sharma to felicitate our keynote speaker.
I'd also request Dr. Vipin and Dr. Sumit to felicitate our session chairs, Dr. Jitendra Mohangiri and Professor Dr. Navneet Kumar. Thank you, sir. I'd request all the dignitaries to please move to the F1 block for the lunch. Thank you.